and welcome to today's Tech Days event, which has got the longest title in the world of Flight into IoT 2 Long Haul. So if you can couple that with Tech Days, it becomes quite long. But before we get going, obviously, we've got quite a lot of content to get through today, but we've got quite a few speakers with us as well. So if we flick across, I'll have a look at what the speakers look like, and we'll talk about that on the big deck of speakers, which is somewhere. So yeah, there we are. There's the speakers. So right at the very top left, we have to my left, Cliff Agius.
Hello, everyone. Yeah, Cliff Agius. I think it's my fault that it's all about planes and IoT.
It definitely is. Yeah.
It probably is, yeah. I'm a Microsoft MVP. I'm also a freelance .NET IoT and Maui Xamarin developer. When I'm not doing that, you'll find me at 40,000 feet flying a plane, hence the link to aviation.
Yeah, that's pretty much it. Well, we had to come up with an idea, and
we did. Why not?
Directly below that on that deck there, you can see Maria-Anastasia Moustaka. Yep. And I'm assuming you're going to say hello, Maria.
Hello.
Ah, there we are. Do you want to say what you do, Maria?
Of course. I am also a Microsoft IoT MVP and a Gold Microsoft Learn Student Ambassador. And I am also a software engineer, and I'm really, really happy that I'm here with you today, even virtually.
Yes, next time we will have you in person.
Join us from Greece. I'll come and get you next time, Maria.
Yeah, no, we'll all go there.
Yeah, we'll all go. That's even better. We've got sand and beaches.
Exactly. Yes. Moving on, I'm going to go to the top right of that, and we have John Lunn. So John, are you able to speak, or you're not able to speak? John is actually now, used to be an MVP like the rest of us, but he turned his MVP in and decided to join Microsoft. So you're a cloud solutions architect at Microsoft, I believe, or something like that.
No, he's not. He's shaking
what
his
is
head.
It? That's something like that.
Specialist.
Well, geez. Well, you know, it's not my job. But yeah, so fantastic. Onwards from that, we've got José Simões, who's joining us virtually. José, do you want to say a little bit about yourself?
Oh, sure, Pete. Hello, everyone. I'm José Simões. I'm from Portugal. I'm CEO of Agius Solutions, one of the founders of .NET Nano Framework. 2 years MVP awarded now. And I love everything IoT related. And I'm happy to be here in such great company.
And where you joined us from?
Portugal.
Portugal, that's it.
Nice.
Yes.
Excellent.
Yeah, and moving on, we've got all the way over on the other table over there, we've got Sander van der Velde.
Yeah.
I don't know if
hello.
we can show Sander, but there he
is. Yeah, hello. My name is Sander van der Velde, and I'm a senior IoT architect at ALT in the Netherlands. And I'm also a Microsoft MVP, and I'm here in the UK. With a flight,
of course.
With a flight, yeah.
And well, we have a lot of fun, of course, about Azure IoT.
Yeah, that's good. And then finally, myself, I'm Pete Gallagher. I'm a full stack dev manager at Avanade, brand new, just a couple of weeks into that job. So enjoying that and bringing my love of IoT to Avanade. So yeah, looking forward to that. So with the introductions done, before we get going too far, we do have a code of conduct in place at this event. Really, there's a lot of words on that slide, but really it means just be nice to folks. This is a nice, friendly, family-friendly event, and we want everybody to get on. So please just be nice, and we'll have a great event. So the agenda for today is reasonably packed, but starting with where we are at the moment, this is just the welcome and the introductions, which is pretty much done. Directly after that, then José, Cliff, and myself will be talking about the devices that we brought with us, and how we're making those work. And then directly after that, oh, no, it should be the agenda. I think it's coming out. Yeah, that's fine, yeah. Yeah, I think, sorry. Yep, it's fine. So moving on from that, Maria-Anastasia, Sander van der Velde, and myself will be talking about stream analytics and how we can process data using stream analytics. After that, then it's going to be Sander and I think possibly Maria-Anastasia, but likely just Sander on his own, chatting through some of the awesome stuff that he's done there with Azure Data Explorer, ADX. And then after that, more Sander. And in fact, what you'll find is there's a common theme because, and we're all super thankful, Sander has done so much work for
Yes.
everything we've done here. We're super thankful. So congratulations on the amount of work you've done. But Sandra's going to then talk about Azure Digital Twins, and that's really cool. You definitely want to stick around because this gets more cool as it goes along, actually. 3D models and all sorts. So definitely check that one out. And then finally, before the Q&A, we'll have John Lunn, and John's going to be introducing us to the Power BI element of this for the visualization. So with that, we're massively over for our agenda already.
The last bit on there, though, Pete, was Q&A.
Yes,
So
absolutely.
if someone has a question, they're watching right now, how do they pose the Q&A to us?
Yes, so you can ask your questions live on YouTube or in the Teams chat. But you can also, if you tweet us on the hashtag TechDays, then we'll have a look at that hashtag as well, and we'll get involved with that. So do, tweet your stories, tweet your questions, and we'll answer them live. This is all live. There's no pre-recorded sessions in this, so likely things won't work.
Yes,
but that's kind of half the point. This is a reality check for IoT. This is real-world stuff we're doing here. So absolutely. So with that, if we switch over to my slide deck, then we can start talking about the devices, the cool stuff that we've got sitting on the desk here. So with that, and hopefully you can see my slides.
Seen the slides, or not sure if we are.
Yep. I don't know if Adam needs to bring them in. Oh, I don't know.
Like we said, things will go wrong.
They will. But as long as somebody can see my slides, then that's all right. Here we
There
go.
we go.
Perfect.
Yay.
There they are. It might just be a delay. It's perhaps time zones different.
But could be that. Yeah, could be, yeah. We are flying to Seattle today, so it is 8-9 hours.
Exactly.
So,
yeah. So if this session is Cliff Agius, José Simões, and myself, and we'll be talking about the embedded devices that we've got sitting here. And in fact, before I even go across, I'm going to flick to my camera, and what you can see on my camera feed here. This is an Ocio cam, by the way. It's a fantastic piece of kit that gives us a downward view of what we're looking at. On the right-hand side, so here you can see. We've got a Raspberry Pi Pico, and then in the middle, we've got an ESP32. It's an ESP32 cam, actually, which is what that part on the top is. And then we've got a Meadow Labs Meadow F7 board to the left.
We have.
So they're the three boards that we're going to be using, and you don't need to be looking at them too much, because really all they're going to be doing is flashing the odd LED, which tells you that this is working. Actually, really, it's for us.
Yes.
Stop.
So we know it's working.
So moving on, we're a part of a journey with what we're going to be showing you, and this slide really starts out at where the devices are connecting up to Azure's IoT Hub. If you've not used an IoT Hub before, it's a gateway at the edge of Azure where you can connect, if you like, millions of devices sending millions of messages, and you'll never get a busy tone. And it allows us to be able to process that data through to all the rest of the Azure services. It does a whole heap more than that, but that's the basic idea for that. The underlying technology is actually event hubs, and then they're built on top of that to give us things like two-way messaging and module identities, but we'll dig into that detail a little bit more. Again, from what I showed on the camera there a second ago, we've got three devices, and what we've got overall is a plane that you can see on the left-hand side, and the plane is our device, if you will. This is the overall device. Underneath that, each of these devices is pretending, essentially simulating data from different parts of the aircraft. So, Cliff, you might, as the resident pilot.
Yeah, well, yeah.
You might want to describe that.
Yeah, so we've got three devices. If we just quickly switch back to this camera, Pete, we've got the Pico here, which is doing all the flight data. That's sending data about where the aircraft is, its lat and long, its altitude, etc. In the middle, we've got the ESP32 cam, which is sending the cabin data, so the temperature of the cabin differential pressure. As you know, when you get on a plane, it's flying at 43,000 feet, but you wouldn't be able to breathe up there. So the cabin is pressurized down to around 7,000, 8,000, 9,000 feet. So that's the cabin data that's coming out there. And then on the far side here, we've got the Meadow board, which is sending all the engine data. So that's essentially pretending to be an engine that's sending all the engine data up. Looking at the code that's running on these devices, the Pico is running Python, isn't it?
MicroPython.
MicroPython, sorry.
Yeah. We'll get to that.
The ESP32 is running Nano Framework, and the Meadow board is running .NET. And
we can actually talk about that.
We can talk about that, yeah.
So we have slides.
Do.
I mean, there's no good IoT demo or slide deck that doesn't at least have the specs of the devices that we're using.
It needs to have, doesn't it?
Yeah, I mean, this is definitely not a filler slide. You understand? People need to understand.
Yes.
So I'm going to talk about the Pico because that's my little baby down here. If you didn't realize, Raspberry Pi have made their own silicon, the RP2040. And to show that off, they've got this Raspberry Pi Pico W, actually, in this case. So the W means that they've now built wireless in, which was one of the things missing from the Pico originally. It's actually a reasonably capable microcontroller. So most folks will know Raspberry Pi for the regular Raspberry Pi 4, as it is at the moment. But that's a full computer. So that needs an operating system and some sort of storage and a keyboard and a mouse and display, perhaps. Whereas this is meant for real embedded tech. So there's no operating system that runs on this. Essentially, you just run your code directly. If you've used an Arduino or indeed the ESP32 or the Meadow, then you'll be familiar with that sort of a paradigm. It's not got a huge amount of storage. And in fact, as we go along these slides, you'll see how that story works, where these devices get more powerful as we go along. But because it's not very powerful, it also means that there's not as much for it to draw power from. However, funnily enough, the ESP32 probably takes less power at the moment. They're working on that.
Yeah.
But either way, these devices are designed to be scattered around exactly like we're doing, collecting data at the edge.
They're £4, aren't they?
Yeah, exactly.
So they're $4. They're super duper cheap.
Yeah, if you can get one. Although they're not as hard to get. Yeah. It's not too bad. So yeah, a bunch of GPIO, which means we can collect data. I've actually got an
General
SD card.
Input output.
Yes, exactly. Yes.
Don't follow IoT words.
Okay. Yeah,
I'll play the game.
You can do that. That's right.
Yeah.
And you can see we're running MicroPython on this, and we'll come back to the code in a minute. But moving on.
We've gone to the Meadow, which is
actually
the far end.
The other end. Yeah, we can do
that.
that.
Going along
yeah, I
way.
did. But
Let's do that. The Meadow is a wonderful board, much similar to the other two. It's a microcontroller board. You've got all the GPIO ports and everything else. But the advantage of this one is it was developed by the team that were behind Xamarin. So some of the developers and leads behind the Xamarin, which is a mobile platform for developing and running your code anywhere, iOS, Android, Windows, Linux, etc., are behind this board, which means they've repurposed the mono runtime. And you can run .NET code, normal .NET, C#, F#, VB if you really want to, if you're that brave. It runs on this board as if you've written it and it's going to run on a Windows machine, or an iOS, on Android machine. It's absolutely awesome. I'm showing off on the slides there, we're showing off the V2, which is an upgraded version. The one on the table is actually the V1. They've upgraded things like they've added more memory and some extra parts on there, which allows it to connect to the cloud and also allow you to send over-the-air updates. So if this is out in the field, probably not why it's flying on an aircraft, but it was in a truck somewhere that stops off at a truck stop, and you're collecting data from that truck. You can send an update to the board from the cloud without having to worry about the fact that you need to get it back to base and plug it back into a PC, etc.
Sending updates from the cloud while it's on a plane is a bit meta.
It is a bit meta, and it's also probably not what you want to do, because you probably wouldn't want to update it while it's collecting data about an engine, because you kind of want to collect the data about the engine. But the advantage is you've got the S10 chip, which is the main core chip. But it's also got, just at the end here, it's got a little ESP32 as well. So it's got two processors, but the co-processor takes care of doing all the Wi-Fi, the Bluetooth, and all the data and network comms on and off the device. And it also takes care of, when you send that over-the-air update, it manages that over-the-air update with the main processor and the main memory. So it's a very clever board. The board that it's plugged into here is the Project Labs board, which is a separate device you can buy from the Wilderness Labs websites, and that allows you to have a little screen. A little screen and some buttons and some BME 280s.
Have you not stripped that off that board yet?
Not yet, no. I don't like doing temperature and pressure, which is why this is all about flight and not temperature and pressure and humidity. But that's a wonderful board. It's fantastic. You get it from Meadow Labs or Wilderness Labs, and you can download it, and it's shipped from the US. It's the most expensive board here, but it's just so powerful. It's really, really well powerful.
Yeah. Is it full .NET that runs on that as well? Isn't
full
it?
.NET.
So,
yeah, it's .NET Standard 2.1, and they're just about to jump to .NET 6. It's just gone RC as well, and so the release candidate's out as well, which is what's running on this board. It's fantastic.
Brian Kostovich would be happy with that.
He would, yeah.
So the next board is the ESP32. These are probably in the wrong order, really.
They are.
You can blame me for that because I made these slides. But hey,
ESP32. This is just the CAM one, purely because that was what was on Amazon, and you can grab one. A pack of 3 from Amazon costs less than £20. So you can see this the Pico's around £4 or £5.
Don't touch it.
They're around kind of £8-9 each, and this is $50 plus shipping for the Meadow. But the ESP32, that's running Nano Framework, which is José's baby, which is much the same. You're going to run .NET C# code. It's just a stripped down version of full .NET, because why would you need full .NET?
And we've got a slide for that next.
We do.
José's
Yeah.
going to speak about
He
it.
is,
But you carry on. You
So,
can talk about the
just
specs if you like.
But the advantage in Nano Framework is that we're using the ESP32 cam just because it's cheap and easy to get from Amazon. But you could use any ESP32 or another, hundreds of devices that you can use. All relatively cheap. It's just that was what I had on the bench when we was writing the code for it.
And this has got an SD card built into it.
It's got an SD card built into it, so we're reading the data from SD cards. It's
cool.
got a little camera that we're not actually using, and it's got Wi-Fi, Bluetooth, all built in, all available. It's
pretty cool.
Great. I get them. If you're looking at the slide there, I get them with these little baseboards. When you buy them, they sometimes don't come with a baseboard, but then you need a special FTDI plug to plug your USB cable into. So I spend the extra, I think it's like 80 pence. It's not a lot to get it with these little motherboards that they plug into, which gives you the boot and the power reset, and also a USB-B port to plug your USB cable in. Which is a little trick.
Yeah. So José, do you want to tell us a little bit more about Nano Framework, which is awesome, by the way?
Yes, it is.
Oh, thank you. Yes, sure. .NET Nano Framework is part of the .NET ecosystem. It's an open source project which has joined the .NET Foundation a few years ago. And we are kind of responsible to deliver that mantra of .NET runs on every platform to the lower-end devices. And when I mean low-end devices, it's really, really constrained devices, not a Raspberry Pi. Something like you are seeing right now, an ESP32 or an ST Microelectronics STM32 series with just a few hundred kilobytes of flash and RAM. And there are ports for other platforms like Texas Instruments, NXP, M5 Stack, and all those tiny devices. And all this, like Leif was saying, it's C#. You just use Visual Studio for the usual C# development that you are used to, from coding to deploying to debugging, running unit tests, all this connected to a real device with a plain simple USB cable. Now, probably some of you are thinking, oh, cool, now I can use C# to blink some LEDs or spend some Saturday after... Yeah, spending some Saturday afternoons cranking a new sprinkler system running on an ASP board, and yeah, you get that right. But know that .NET framework, Nano Framework, it's production ready. We have devices deployed in the field for some years now. Just the other week, we passed the 6 million NuGet downloads, which is pretty impressive. And to give you some examples of devices that are out there in the field, we have devices generating telemetry data, and this is commercial devices, generating telemetry data for solar power plants, running industrial controllers, deployed in the desert, attached to fuel tanks, powered by solar panel, and sending the monitoring data through a satellite connection. All that is pretty cool, and that you can do with very, very small and resource-constrained microcontrollers. And there are professional libraries to connect pretty much everything: sensors, devices, screens, and there are also a lot of libraries distributed as NuGet packages. One of them that we'll be seeing next, the Azure one, connecting to IoT with all that good stuff with digital twins, device provisioning system, commands, support for modules, and all that. So basically, in a nutshell, this is .NET Nano Framework.
Yeah, very cool. Yeah, so demos, in fact. So
should we start with the Nano Framework on my machine, and while José's here, we can talk through that. And
yeah, go ahead. Yeah.
So we just switched to my machine, this one here.
What which other machine have we got?
Well, I don't know. I've got a couple at home, but yeah. So this here, we're in Visual Studio 2022. So the latest and greatest Visual Studio. You can use 2019 if you want, but I'm using 2022 here. You install the extension, and that gives you this new tab, which is your Device Explorer. You can see here, I've got the ESP32 plugged in. So you can see it's on COM port 11 for me. And we can do things like we can look at his network stack and edit his configuration, etc. as well. And we can ping the device, make sure we're talking to it, etc. The other thing we can do as well is you can see here, we've just got a static void main. So it's just normal here. And we've got a GPIO controller, which allows us to talk to that general purpose input output. This is all bog standard stuff. So we're setting up the pin to flash the LED, etc. We're connecting to Wi-Fi here so that we can get the ESP32 to talk to the Wi-Fi network. Because we're in the Microsoft building here and there's a page between the Wi-Fi and you have to click the accept the terms and conditions. We're just tethering off of our mobile phones. But if we get success, we then got debug.write line because he doesn't need a debug.write line to get to say what's going on. But if we come further down, we are connecting to the IoT hub here. So all your normal, Visual Studio items are there, just as you would. So we're just using an X509 certificate, which is the security, and you'll see a Baltimore one here. And when you go out to the GitHub repo and download this, just be aware that the Baltimore is going end of life, and I think it's early next year.
Yeah,
I can't remember the exact date,
I think it might be February 2023.
Yeah, so there's a new one out there.
Sanders shaking his head.
Yeah.
You got a proper date for that? No, I think it's still working.
No, it's still working at the moment. I
think it's 2023. Yeah.
So
April, May or something.
Yeah.
It means your devices won't be able to connect anymore. This is the SSL element that works under, because all of the communications between these devices and the IoT hub are encrypted using an SSL certificate, which is what that Baltimore certificate is there. And Cliff will talk a little bit more about it. But obviously, when they switch that certificate out, it means that you're going to lose your trust and the device isn't going to be able to connect anymore. Bad. So plan ahead.
Yes. I've not planned ahead. The reason I use the Baltimore one in this is because you have to get the key and turn it into base 64 encoded, etc., so you can store it in memory and put it on the device. And then we a device client, just much the same as if you're using that Azure.devices. I've got what it's called now. Azure.devices.
It's the IoT.device client.
IoT.device client. That's it. Azure.IoT.device client, which is the SDK from the Azure IoT team. This Nano framework is basically modeled that, and it's exactly the same. So we can go here. You can see that we need to give it a string for the IoT hub, device ID, module ID, and then the SAS key as well. So I grabbed these from the SD card. So rather than having to burn this code every time, we could have 1,000 of these devices and just have an SD card with different data on them and just plug them into the device and off it goes and does its thing.
Obviously, in the real world, would encrypt that SD card, but we're not doing that.
Yes, we're not doing that today, no. And then we open a connection. And as long as the connection is open, we're then good to go. We have a worker thread, and you can see here, we're flashing the LED as it does. And then you saw earlier, the LED is flashing on the screen. We have some warnings, so we can send some messages to the device to say, pretend that you're at high altitude and, that sort of thing. Which Sandra
you might see that later. Yeah.
You might do.
Spoilers.
And then we send the data packet is down here, and this here is.
Did you zoom in a little bit?
I can zoom in a little bit. There we go. Is that better?
Yeah. That's good. Yep.
And to send the message, all we're doing is taking out our JSON payload. So what we do is, because the memory of the ESP32 is quite low, so it's 256 meg, I think it is, or something like that. And the data for this flight from London to Seattle, which I'm sure Adam can pop up on the screen shortly, shows the flight going across. There's a lot of data points, and that wouldn't fit. As you can see here, we're somewhere up over the North Atlantic now.
We'll come back to this slide.
Yeah, we'll come back to this slide again and again and again. But you can just see that's the flight. It's taken off, and these modules are all pretending to be on a 787 going all the way.
They really are. No, they are. Yeah. Don't spoil the effect.
But what we're doing is, because all those data points are too much to fit in the memory of these devices, we put them on an SD card and broke them up into chunks. So 50 device reports in each chunk. So we read that from the SD card, and you can see here we bring it into the engine data model, and then we're sending that with device client.send message. We send the payload, and then we just have a 2-second timeout because it's awaited, and we cancel that token as you would with any C# project you work on. And then a bit further down, we send the packet, and then we flash the LED off or on. Actually, no, it's back to front on the ESP32. So you have to set it low to turn it on, and high to turn it off. Don't ask me why. And then we carry on round. You've even got some exception handlers as well. So this is all normal, bog standard C#, the stuff that you know and love. You can set breakpoints. You can, have all your different projects and have all your different modules and models, etc. So, if we go into the cabin data model, it's just a normal data model,
just a
normal class, with date time and strings and floats, etc. If we go into, I've got a data store, which is the bit that actually is reading from the SD card. So we just initialize the SD card, and that's it. That's all we need to do.
Jose, which version of .NET Standard is Nano Framework? I forget now.
We are kind of scattered throughout several frameworks because as we don't use the libraries from the standard distribution from the full .NET, but we try to have all the same APIs, at least the main ones that you found on the full .NET. So there isn't exactly a version that we are attached to, but we try to bring all the good stuff as quickly as possible.
Yeah, all the shiny stuff, all in there. The point I'm making is that this is all up-to-date stuff. So we've seen stuff in the past that becomes out of date really fast, and Nano Framework is well supported and well maintained. It's open source, isn't it, Jose?
Yes, 200% open source, from the libraries to the tools to the Visual Studio extension, the CLI tools and all that stuff, even the pipelines. You can just go and grab it all.
By the way, so just like me asking questions, don't forget you can ask questions there in the Teams and in YouTube or on the social hashtag Tech Days. Do just ask whatever you like, and then we'll get prompted. And if it's particularly pertinent, then we'll interrupt. And
so you can see here, if you put Nano Framework dot and then your favorite C# library, Azure devices.client, you got system.collections, all those sorts of libraries are there. If they're not, then reach out on the GitHub and let the team know, and we'll see if we can help and jump on it as well. Well, not me, but Jose and the team. But that's the ESP32. Which one we're going to jump onto next, Pete? We're going to jump onto the
well, you do your Meadow because you're already sharing, so
okay.
you'll stick with
so
you sharing.
I
see. You should have used virtual desktops. Look.
I should have done. You taught me that earlier, didn't you? I should have done. So jumping across the Meadow, which is on the Project Labs board. Again, this is using the mono runtime underneath. And if you've done anything with Xamarin or Maui, you'll feel right at home here. You jump in with a Meadow app and it creates an app and Feather V1. If you buy a board from the store and you do a file new project, this will be V2. But if you've got an old board like me, you have to just change that to a 1. And then it's much the same. The code is almost identical. We set up the onboard LED and we get the settings, which from memory, because the Meadow board has got a lot more memory. So we could store the whole JSON packet in memory rather than in an SD card. And then everything else is exactly the same. The thing is with the Meadow is it's using the native Microsoft Azure devices.client rather than one that the Nano Framework team have taken and stripped out all the big things that kind of a microcontroller doesn't need, because they're for big edge devices and things like this that you're not going to run on a microcontroller, certainly one that's device constrained with memory, etc. The Microsoft Azure devices.client that Meadow are using is all in. And then what they do is they run a JIT over that, which then strips out all the bits that are not needed. So you're not storing everything down to the device, but everything works. And you're using bog standard, system.io, system.threading, text.json. So new JSON serializer and deserializer from Microsoft. Instead of using Newtonsoft, you can just use the bog standard Microsoft tooling. So that is, the Meadow in there. I could go through and show you the code, but it's exactly the same as the ESP32 stuff. It's doing the same stuff, except just here, because there's a subtle difference between the two different Azure connections. This one is using the module client, and it's using a create from connection string. So we create the connection string, and then we connect with the module client. So that is the Meadow as well. So should we go across the peak? I'm just aware of our timing, because me and Pete could talk about the electronics and the devices for hours, and then poor Sander would have no time. But Sander's stuff is really, really cool. So we're going to get to that as well. So how do we talk about the Pico, Pete?
Yeah, actually,
Pico, Pete.
Don't do that.
No, okay.
Yeah, we're not that much different in size. So the difference here is the Pico is not using .NET. As it happens, Jose, it's in the pipeline, isn't it? Nano Framework for the Pico.
Yes, it is. It shouldn't be too far away, but I don't have a release date yet.
Yeah, soon. We can say that confidently.
Uh-huh. Yes.
How
So
cool would that be? The fact you can get a $4 device from Raspberry Pi made in Wales
Yeah.
and run .NET on it. That would be super cool.
Yeah,
Yeah.
no, it is. And yeah, I wanted to use it, but Jose warned me off from using that. So we're using MicroPython. If you don't know what MicroPython is, it kind of speaks for itself. So you will have likely have heard of Python, lots of tabs. But MicroPython is a little bit like what Nano Framework is to the full .NET framework. It's a more constrained, precisely targeted version of Python, targeted at controllers like this. So it gives you those extra layers for general purpose input-output, GPIO.
Yep.
And that's what I'm using here. So this is going to be a similar sort of setup to what you saw Cliff using, in that I've got an SD card connected to my Pico, and I'm reading the data off of there, but I'm actually reading the settings from another file that I've stored on the Pico itself. I could easily have put that on the SD card as well, but I didn't. We bring in a bunch of stuff here. Now, because this is MicroPython, I've not used the full SDK to make this work. Underneath the hub, underneath all of the IoT hub, we're using something called MQTT, which is a messaging protocol, a really small messaging protocol that uses a publish and subscribe mechanism. And we can interact with the IoT hub at that level if we like. And that's what we're doing here. So for resource restricted devices like this, it's a really good way of doing it. And Cliff kind of alluded to it with Nano Framework, where they've had to strip out a lot of stuff to get it to work. If you want to strip out even more, then you can talk direct MQTT. But there's more to it, because obviously the libraries, they handle some of that complexity. I'm not going to dive in too much into my code because we don't really need to, but we read some settings and set some variables. And I'll zoom in just a little bit and move this down. Actually, at the bottom, you can see the live data coming through. So if that sort of stuff interests you, you can see each time it sends it once every 3 seconds, theoretically, then you'll see that message change at the bottom. That's going to move it down, give us some more space. We've got the host name, the device ID, and the module ID. Cliff didn't mention it, but it's worth pointing out. If you joined us last year for Flight into IoT, each of these devices connected to an individual device in IoT Hub. So you get an identity for a device in IoT Hub. Beneath that, we can use something called modules, which allows you to be able to split out each of your different device capabilities into a device of its own. And it connects with its own connection string, but you can give permissions to folks so that they can't interact with those other devices. So it gives you a bit of granularity.
So in our case here, the aircraft is the device.
Yes.
And these modules are the different parts of the aircraft, so the different computers sitting on board the aircraft.
Exactly that. That's right. And we'll see this in the story as we go forward.
See there on the side of your VS Code.
Yes, exactly.
There you got the modules, flight, engine, and cabin.
That's right. Yeah, exactly that. So that's what these are highlighting on the left-hand side. And then we need these things here, these topics, and that's how MQTT is working under the hood. So you subscribe to a topic, and it's a little bit like a hashtag on Twitter, really. And you're expecting messages to come through with that topic. You intercept them and do something with them. Likewise, we need to publish to a particular topic for the IoT Hub to receive it. So that's what these two lines are doing there. And then we connect to the Wi-Fi because we need to do that. And then we've got a direct method that we use. So we can send a direct method, invoke something on the device, tell it to start the flight, which is what that part's doing. Then we connect to the MQTT, which again uses that same Baltimore certificate that we were using earlier. Obviously, if we fail, then we can reconnect. And then a few more functions about sorting out dates and times. Interestingly, there is a real-time clock on board the Pico over here, but you need to set that time for that to work. Once you've set it, it will carry on. And then we set up the serial peripheral interface, SPI, a serial interface to the SD card, which means we can then mount that as a filing system and start reading the data. After that, then towards the bottom, we just wait for that direct method to happen. And once it does, all the way down at the bottom down here, it says trucks away, because, you know, Cliff probably hates that term, you know, but I like it. It's good. After that, what it does, it reads all of the JSON data from the SD card. We've sped it up because we're flying from Heathrow to Seattle, which is like a 9-hour flight. And we're doing this in less than 3 hours. So we've actually sped the data up. And each one of these is essentially grabbing the JSON, and then we publish out using the client that we created above. That topic that I mentioned, so the published topic, and then just a dump of the JSON data. And that's kind of what you can see happening at the bottom there. And actually, I could stop the flight with emergency landing at 30,000 feet, which would be dangerous, but it literally just stops. Like manifest, it just disappears and comes back 5 years later.
Yeah.
So that's the concept of what we've got here. Obviously, we've not dove into detailed in what we've been doing, but all of this code is on GitHub and it will be made live later once we've squashed all the changes and got rid of all of the keys that we put in there.
Yes, yeah. But let's talk about the data, because there's a fun thing we had to last year. If you come along last year, you'll see the fact that we grabbed the data from a Raspberry Pi that was connected up and sending data up to Flight Radar 24. And so we grabbed the flight. This year, we wanted engine data and cabin data. Flight Radar 24 doesn't have that data, but one thing does, and that's Microsoft Flight Sim. And so what I did was I set up Microsoft Flight Sim, wrote a .NET MAUI app because I needed a very quick Windows app to connect to Microsoft Flight Sim. So
you notice how he's nonchalant when he's saying this? Yeah.
Well, if you've not tried .NET MAUI, go out and give it a try. So I wrote a .NET MAUI app that connected to Microsoft Flight Sim, and then I literally sat in my workshop and flew an aircraft in Microsoft Flight Sim for the full 9 hours from Heathrow all the way across Seattle. Obviously, I got up into the cruise, engaged the autopilot, when I made the kids some dinner or burnt them some dinner. I did some other things and then come back. And if you look at the end of the data, there's a bit where it's about 15,000 feet, about 12 miles from Seattle, and I had to go into a deep, steep spiral dive to get it into the runway. But that's purely because I come back, I'm that close, and quickly landed the aircraft.
We might see that in John's session.
We probably will see that in John's
session. If it works all the way through to the end, we might see that in John's session.
But that's how we got the JSON data. So the .NET MAUI app collected the data from Microsoft Flight Sim using a tool called FSUIPC, which is a paid-for tool that plugs into Microsoft Flight Sim, allows you to grab all the data out. We then converted that into JSON payload and then split it up into sections that have been put on the SD cards with various devices here. So a very cool way of grabbing data if you need some real data that isn't just temperature and humidity.
That's good.
It is.
So I'm conscious of time. So if we switch back to my slides, we've got some call to actions here. We probably could have added loads, but you know, there will be plenty of time for that. But one of the things we'd like to make sure that folks know about is that there's a specific Microsoft certification for IoT developers, the Microsoft Azure IoT Developer Certification. There's actually a speciality flavor of that, but it's the same exam. So definitely go check out that exam. If you want to take your IoT career to another level, that's definitely something you want to go and do. I may have had involvement in creating it, possibly. There's a lovely Microsoft Learn course that you can go and follow along with that as well. And that's definitely worth checking out. That's curated by the Microsoft folks, so check that out. Onwards from that, there's actually a Pluralsight course that I may have helped create as well. So if you want to follow along with the course with somebody that may well have written part of the exam, then you probably do no better than go check that out. And also, if you want to go and check out how you can connect your Pico to the IoT Hub, then there's a blog that will help you to do that as well. So do go check that out. And I reckon at that point, we can move across and bring Maria-Anastasia in and Sander, and we'll kick this guy and make him move across.
Am I on?
You can go stand where Sander was standing.
Stand over here.
Yeah, you can do that. Yeah. It most likely will be firing questions our way anyway, so you can stand there. It's comfy where he's left you a nice warm spot. You don't need to go anywhere. It's fine. So at this point, we've got the wonderful Maria-Anastasia Moustaka and Sander van der Velde. And at this point, we're going to talk about Azure Stream Analytics and how we can process and interact with the data that our devices are sending. Are you there, Maria-Anastasia Moustaka?
Hello, I'm here.
Live all the way from, exactly, that's right, just a plane journey away. Did you want to go through your slides and tell us all about Azure Stream Analytics?
Of course. And if you want to interrupt me, you are totally free to do it. So together we are going to talk about Stream Analytics. Here is the part of the system diagram that's already done. But how can we react? How can we react on alerts, events, and anomalies? So, with me and the valuable help of Sander and Pete, we are going to examine this. We are going through the data processing with Stream Analytics. to process data and use the anomaly detection functions to detect issues with the airplane during the flight. As you already know, our devices, excuse me, the previous slide. As you already know, our devices in the airplane are sending flight data, engine data, and environment data, and all this data arrives in the Azure IoT Hub. So now we will examine how the Azure IoT Hub can send this data to the Stream Analytics and how the Stream Analytics job sends all this to different event hubs and then one of them to the Logic Hub. So now we are going, oops, a technical issue, I think, with my slides.
We're live, you know, these things are going to be happening all day, so get used to it.
I'm going to share it again.
Let's have a look. Let's just wait for Maria-Anastasia's slides to come back. Yeah, I mean, this is a good point, actually, while you're doing that, to talk about what we've got going on in the background. Really, you can see on the screen here's a spoiler for John Lunn's session, but we like to bring this in because it's giving you a real-time view of where our flight is. As I mentioned, we're sped up by 3 times. So we're way ahead of where we would normally be in the real world, but we should be coming into land towards the end when John's giving his session. So I think we may have Maria-Anastasia's slides. So if you want to switch back to Maria-Anastasia's slides, then we're good to go. There they are. Brilliant. Yeah, carry on, Maria-Anastasia.
Yeah. Okay, I think that all will go fine now. So let's talk a little about Azure Stream Analytics job. So Azure Stream Analytics job is a powerful and easy way to ingest, analyze, and deliver large volumes of streaming data. But warning, Stream Analytics does not store data, but it ingests it and makes decisions. Patterns and relationships can be identified in data that originates from a variety of input sources, including IoT devices and sensors, of course. This data can send to Azure IoT Hub and from there to an Azure Stream Analytics job. These patterns can be used to trigger actions and initiate workflows, such as creating alerts, feeding information to a reporting tool, or storing transformed data for later use. I hope my slide is...
It's all good, Maria-Anastasia. It looks good from here.
Yeah, great. So, Azure Stream Analytics offers an SQL query language for performing transformations and computations over streams of events. This language has some extensions like the windowing functions to aggregate data in the in-time windows. Here we have an example for a query, and we're going to see our queries in a few minutes. And now we are going to move on windowing. In time streaming scenarios, performing operations on the data contained in temporal windows is a very common pattern. Stream Analytics has native support for windowing functions, enabling us to author complex stream processing jobs with little effort. At the moment, there are 5 windowing extensions, as you can see here, and these are tumbling, hopping, sliding, session, and snapshot. A little words about each. Tumbling window functions are used to segment a data stream into distinct time segments and perform a function against them, such as in this example. The key difference of a tumbling window is that they repeat and not overlap and an event cannot belong to more than one tumbling window. Hopping window functions hop forward in time by a fixed period. It may be easy to think of them as tumbling windows that can overlap and be emitted more often than the window size. Also, events can belong to more than one hopping window result set. Now, sliding windows, unlike tumbling or hopping windows, output events only for points in time when the content of the window actually changes. In other words, it happens when an event enters or exits the window. So, every window has at least one event. Similar to hopping windows, events can belong to more than one sliding window. Next, we have session window functions that group events that arrive at similar times, filtering out periods of time where there is no data. And last but not least, snapshot windows group events that have the same timestamp. So, next concept we are going to examine together is the anomaly detection. Azure Stream Analytics also has built-in machine learning-based anomaly detection capabilities that can be used to monitor spike and dip, trend changing, and level change. Here we have an example in which the temperature comes in, and for each 120 data points are compared, spike and dip are raised with a 95% certainty. Okay. So, apart for creating and running Stream Analytics through Azure Portal, we can also use the Azure Stream Analytics Tools extension for Visual Studio Code in our local machines. I know that most of you probably will love Visual Studio Code. So if you are a fan of this, you have to try it for sure. With this extension, we can create, start, and stop jobs. We can also export existing jobs to a local project, list jobs, and view job entities. And last but not least, we can view job diagram and debugging in Job Monitor. And we are probably see it live near the end of this presentation. So the time has come.
That one. But either way, I agree with the sentiment that you've just made there. Visual Studio Code. I spend most of my life in Visual Studio Code now. It used to be in full fat Visual Studio, but absolutely, as an IoT developer, we can be in either of those two places now, which is fantastic. At this point, we're going to switch across to my screen, and we're going to start looking at crossing the streams, as this slide quite rightly puts. But actually, that's one of the things we specifically need to do for Azure Stream Analytics, is make sure that we can combine multiple data sources together and process them and use them. So yeah, if we switch to my screen share, then we can see what is essentially the Azure Stream Analytics page in the portal. And what we're looking at on this page is what's known as the job diagram. And it's in preview, but don't worry, it's fine. It's good to use. And it gives us a really good overview of the different component parts that Azure Stream Analytics are helping us to use. So right at the very top here, we have the IoT Hub input. So this is where the data is actually coming in to Azure Stream Analytics. And we're collating all of that together.
Lower. There's a plus and a minus. brightness.
Yeah. I'm zooming in, but it's good so folks can actually see those bits. So this is the main input. This is where it's actually coming in.
Yeah.
And then below that, we've got an in-memory table. And Sandra, do you want to explain why you've had to do that?
Well, the IoT hub ingests data from multiple devices. Each device has its own identity, and data flows through the IoT hub and can be picked up by other services. And it's just like acting like an event hub. So that means that we also have to consider the number of consumers of a service. Each consumer, that could be Azure Stream Analytics or the Visual Studio Code, which has that nifty tooling that you can see the live stream, or later on, as we will see, Azure Data Explorer, those are all consumers, and they probably all want to have a copy of the same message coming in.
Yeah.
And there is the challenge to get a copy. They must be registered as a consumer group. Although luckily the default consumer group behavior is that you can have something like 5 consumers and there's some copying inside the consumer group. But as you can see, we are splitting the data into multiple outputs.
Yep. Each of these at the bottom are the outputs, and we'll dive into the detail of this as we go through. But if you imagine, for Stream Analytics purposes, we have an input, and we can see that input at the top. And then a query has its input as well, and we'll see this. And then each query will output. And the fact that we're drawing data from each of these queries means they're all consuming data. That's a problem, isn't it?
Yeah, because at this moment we are consuming the same message 7 times.
Yeah.
And there's that limitation of maximum of 5 copies.
Yep.
So if you would say, okay, I just consume the same input multiple times with a query, multiple queries, you will get an error. And to fix that, we first make a, let's say, an in-memory table, something like that, or a bucket with data.
Yeah, that's that one there. So what we can do is, so you can see that the top level here, we'll actually switch over to the queries and we can actually see how this is working underneath. So on the menu on the left, we can switch to query, and that will give us a pane of glass view over all of the queries that we've got running at the moment.
There it is already.
So
we see that there's a input. It's called IoT built-in route input, and every message from that input will be put in this IoT telemetry. It's just like acting like a temporary table. And all the logic beneath will make use of that temporary table with all that data.
Yeah.
The logic inside Azure Stream Analytics will decide how long that temporary table is filled with telemetry. If it's not in use anymore, it will go out of memory.
Okay. Yeah.
Well, and that's how the query language can be used, and it's a really powerful query language. We see here something with anomaly detection.
Yeah, one of the things, I mean, you're talking about that we build these queries up so that they can depend on each other, and you can draw data and then draw data from that query into another query, and you build your queries up that way, which is what we're seeing here essentially, isn't it?
Yeah. Together, this is called a job. So a job can have multiple queries. In this example 7. And here we see the example of a anomaly detection. We can see something like the anomaly detection spike and dip in red. And all we have to give it, it's a piece of mathematical logic.
Yeah.
And it says, okay, within a 5-minute duration, I'm expecting something like 100 messages for engine data, and I want to have with a certainty of 95% detected if there's a spike or dip. So if the data is flowing and suddenly there's an anomaly, there's a spike or it dips down, then it says, well, that's strange. It will give an event, a message, and it will send that to the output.
Yeah. Maria-Anastasia, you showed this in your slides, didn't you, where essentially we're looking over a certain time period, essentially, but it's looking for these blips of data that are out of bounds with the normal data, and it's using AI in the background here to develop that as an algorithm and use that. It's pretty powerful.
And you can see with the from that it's from the telemetry.
Yep, just here. That's coming directly from that in-memory table, yeah.
And and also this is a new memory table.
Okay.
Because we get that anomaly detection spike and dip scores field column. But if we go a little bit lower, then you will see that we split it up into both the score and the Boolean value, or an integer value in this case, if it's true or false, if there's an anomaly. Of course, it's a guess. It's mathematical stuff. So there is a chance for false positives. So you have to train it about the amount of messages, the duration, and the certainty. That takes some time, and well, I recommend to also use it together with actual factual information.
Yeah, but you could use it where it sends a prompt to an actual real person who then goes and has a look at that data stream, and perhaps he can look at it and discount it entirely because maybe something happened that was real and we can adjust for that. But it could be if we're looking for issues perhaps with the failure of an engine maybe. And I mean, we're fudging this a little bit, and I'm hesitant to use the word fudging, but some of this obviously we're doing it this way to make it work. But in the real pilot sense, with our friend Cliff Ager, sometimes he screws his nose up and says that's not really going to happen. But engine torque, essentially, that's what engine pressure ratio is. It's the amount of load on the engine, isn't it, Cliff? So if imagine if a seagull hits it, then I guess something like that might change, which would be bad.
It would, yeah.
It happens.
It does happen. Yeah, I've had bird strikes.
Yeah, it's bad. So, but you could use this information to retrospectively go back and perhaps use it as a predictive analysis tool to be able to figure out that an engine's on its way to failure and catch that a long time before it actually fails, and perhaps somebody has to squirt a bunch of gas into it and ruin it.
Well, on the aircraft that I fly, all the engine data is live streamed via satellite back to Rolls-Royce, who manufacture the engines. Yeah. So in live they can see what's going on with all their engines globally. Yeah. And it's all just IoT. It's all modules like this. Obviously, a little bit more sort of complex and set up. So it all goes back to their data center where they collect all this data, and then they have AI models that roll over it. I've landed before and been met by engineers that have told us that they need to go and change a part on the aircraft. It's like, well, there's no problem. We see it's but we can see it's about to fail. Yeah. So your predictive maintenance and your schedules, you can work to the data rather than, well, we're just going to change this part every 3 months because that's the safest thing to do. Well,
the reason why they do that, I didn't realize until relatively recently that people don't buy engines anymore. They rent them and they pay for essentially the air miles on them. Yeah. And so Rolls-Royce are the people that actually own those engines. So it's in their best interest to keep the thing running, because if it's not, they're not getting their rental, I guess.
Exactly. Yeah.
So it's interesting. And obviously this applies to other things other than engines, but we can use that for a lathe, for instance. If there's a guy standing next to a lathe, then we don't want that to explode. It would be bad. So yeah.
Well, this is a example of logic provided by the query language. The query language is quite extensive. For example, geo fencing, that's in there by default. It's not demonstrated today, but there are many more features that you can add. I put in some extra functions written in JavaScript because this was written in the portal, but I suggest not to do because there's no version control and testing is
nothing. It works though, yeah.
It works, and it's nice to give a demonstration like this because people know the portal, so this is familiar to them. But you can also add machine learning to it. If you have some machine learning written and made available as a service, you can attach it also. And each time a message is connected to that machine learning module, logic, it will be executed and there's a response.
Yeah, I like it. What's this doing here where all data?
Yeah, well, this is the catch-all. Everything inside the terminal is sent to another output.
Yeah.
It's a event hub also in this case.
Mhm.
This is more for if you're trying to test something and try to figure out how it works.
Yeah.
Then you have a
Like an engineer's view of everything.
yeah, then you have a good knowledge about it. But a little bit later on, we do actually the same, although I filter on model ID. If
Okay.
it's an engine, then I can do the calculation for endurance, which
Yes,
is
this is your UDF. This is your user-defined function we just showed a second ago.
correct.
Yeah.
So I calculate the amount of hours that we can still fly because we have some fuel on board and we burn a number of kilograms of fuel per hour. So then we know the endurance.
Yeah. We keep looking at left every now and again to get these terms right because, you know, the number of times that we've said something and Cliff's gone, no.
I learned a lot about.
Yeah.
Well, actually, I learned a lot about airplanes.
Yeah, that's true. That's
And
good.
well, the calculation from Celsius to Fahrenheit, that's fairly straightforward.
Yep.
And this is the flight data, and we don't touch it that much.
Yeah.
And here's a sneak peek. The Power BI was coming along.
Oh,
There's
yeah,
a
that's-
Power BI
yeah,
output. And last but not least, we have a alert where we get. Can you make it a little bit larger that section?
No.
No, can you?
No, I can go that's as much as
Okay,
it will let
well,
me do.
then we have to do it in twice. Well, for every 20 seconds, we look at the incoming telemetry. And it's filtered with a where clause that we are only interested in the cabin data.
Which is
And then we, like a group by in SQL, we do a group by on a certain device, the device and the module in there, and we do a tumbling window for every 20 seconds.
Yeah.
And because we have a group by, the fields within the select part must be a aggregation. And in this case, we do the aggregation of what is it already? I forgot it. We changed it recently.
yeah,
It's-
cabin altitude.
Correct,
Yeah.
the cabin
No,
altitude.
altitude. We had it spelt wrong in the JSON and everything. Like 20 minutes before the start of the session, we realized that. And like, we probably need to change that typo.
So the alarm is all about if the altitude is too high. If it's, you already explained.
Yeah, if it goes above 14,000, that's when you get the rubber jungle, as we call it, which is all the oxygen masks drop down in the cabin. So we get a warning in the flight deck to say that we're above 10,000, and that gives us a little bit of time to try and sort something out, like descend or put the oxygen masks out for you. But if it goes above 14,000, then the pressure sensor in the cabin will drop the oxygen masks. But obviously, you know, this is sending data to the ground, and with your queries, it would let the ground team know back in the office the fact that actually that aircraft is in a major emergency now because all the oxygen's gone and the passengers on oxygen masks. So it can start teeing up like teams that are going to meet the passengers because they're going to be a little bit stressed out, I'm imagining. I mean, you know, oxygen mask on, it's probably going to stress them out.
Receive manifest.
I've got to watch this program now.
Yeah.
So we have the alarm, 20 seconds long. There's a average of a high altitude.
Yep.
It's in the where clause just
It is
below.
down below. So that's what we're sending out, isn't it? This top part is selecting the data you want to send out. So this is what's going to end up at the output, isn't
There's
it?
an alarm, there's a detail, there's a proof.
And down here is where you're doing the logic of that particular query. So this is where you're doing the bits there, those two.
For those who are online and look at this and they have a SQL Server or a T-SQL or a Oracle SQL,
MariaDB.
whatever SQL version background, they will understand this.
Syntax,
The only thing is there's these into. So you collect it and you send it into another output. And in this case, we send it to an event hub, and behind the event hub,
we have a logic app, actually. So we're not going to trigger this just because trying to get the timings to work on all of this is difficult. But as Sander just said, and Maria explained originally, we've got a set of windows that we can compare data over. And we were using a tumbling window, actually, to make that work. And if we get a condition that goes outside of what we've specified there, it will send a message with the alarm signal out to an event hub. And what we've done is hook a Logic app up to an event hub. If you've not used Logic apps before, then firstly, why not? Because they're fantastic. But these are meant for sort of business processes, really. It's a way to get folks that aren't sort of hardcore developers to be able to create really good business flows. And I use that word specifically because there is also Microsoft Flow. This is a cousin of it that's a lot more powerful. We can reach into any Azure service we like pretty much, or any external API or anything like that to do what's called the trigger element of a Logic app. We then run through a bunch of things with that data that gets delivered. In this case, it's a message telling us it's an alert. And we can use this parse JSON here to be able to grab that JSON packet and grab the bits out of it and then do something with it with the condition statement. And you can see we've got a true and a false. We get a false whether we want one or not. We're not doing anything with it. And in the true, we send an email out to the email address that we specify. And I mean, it's a little bit contrived because you perhaps wouldn't send an email because, you know.
Probably
maybe,
not.
No, maybe
A ticketing system.
Something, yeah.
But why not? There's a plus in there. You can add a second step if you want.
Yeah, anything
or a
you
third
like.
or fourth.
Yeah.
So, and it's actually a flow diagram. So if there's a false part, you can put something in there too.
Yeah.
It's even possible to send an email with a button in there, true or false or yes or no.
Interaction.
And there's interaction.
Yeah.
And then the flow continues.
Yeah. Actually, Maria-Anastasia, you've got a slide on the Logic app element of this, haven't we? So if we switch back, you can close out your session. And I know you've got some call to actions in there as well, haven't you? So let's switch back to Maria-Anastasia's slides. If you're ready, Maria-Anastasia, that is. And we'll let you close out.
Of course. So I'm going to do my closing, right?
Yeah, you can flick through the rest of your slides and then we'll go on to the next session.
Okay. So here is our updated system diagram. Our devices in the airplane are sending flying data, engine data, and environment data, and all of this data arrives in the Azure IoT Hub, as we said before. Next, Azure IoT Hub sends this data to the Stream Analytics as a rule engine to ingest data and use the anomaly detection functions to detect issues with the airplane during the flight. After that, Stream Analytics job is sending all this data to different event hubs, and one of them is attached to a Logic app for sending emails with alerts, as you showed before. So here are some helpful links. As you said, as you've seen before, here we have the IO developer certification, and below this it is the course, the official Microsoft Learn course for this certification. Next, we have the Pluralsight course for this exact certification, and it's very, very helpful. And if you like IoT, you have to deal with it, I think. After that, we have the Stream Analytics documentation, and last but not least, we have some documentation for anomaly detection in Azure Stream Analytics. So thank you very much for hearing me, and I think that Sander will continue.
That's right. Yeah, exactly. So thanks so much for that, Maria-Anastasia. And I mean, it's a fascinating area, and it's certainly Stream Analytics is a little bit out of my comfort zone. And I know that you've pushed yourself into that same area as well. So thanks so much for giving us all that fantastic information. So at that point, we're going to move across to the next session, and we've got Sander van der Velde talking about Azure Data Explorer.
ADX.
ADX. Yeah.
Yeah. Yeah, ADX. It's such a broad topic, and it's such a large topic.
Yeah.
To squeeze it into 20-25 minutes, that's a challenge. But
You'll manage
okay,
it. You'll manage it.
yeah, heyo, here we go. So this is the solution that we have right now. We have the sensor sent to the cloud. It's picked up by the IoT hub, and it's distributed both to the Stream Analytics job as events, but it's also stored in a storage account, because all the raw data, well, maybe it's interesting to look into what's happening inside those devices. Like Rolls-Royce, they are interested in data, even data from years ago, maybe. So storage account, that's quite a common solution. And that is one of the ways to look at the data, because there are different ways to look at data. First of all, like the alerts that we have seen and anomalies, that those are events you want to react on them directly. Maybe with a rule engine like Azure Stream Analytics, but well, something happens, something has to be alerted. Next to that, that's more like the storage account. We get all that raw data, and we just put it in a bucket or in a file. The cheapest way to store it, and well, maybe at some point in time we will look at it, and well, maybe there's some value in there. And if you look at it and you find that value, for example, a certain trend or a anomaly, or maybe some reporting that you want to do, that's called the warm path. And that's where you take the raw data and aggregate it and filter it, and you squeeze it into some form. But well, the raw data is still there, but that raw form, yeah, it's maybe valid for a few weeks, months, of years, and then you throw it away. But the raw data is still there. So if we look at the current solution that we have with the IoT hub, the data are put in a storage account, and that's nice. But the actual aggregations is not so handy, because it's just files. And if we look at that, then let me look here. Here is the storage account, and here is the container. It's called a cold path container, and I have to look into the files by going a path. On my screen, you can see that there's a path. I'm building it up.
Can you zoom in a little bit there, please?
Sorry?
Can you zoom in a little bit? It looks a little bit.
Yes, I
yeah, just a little bit.
can make it a little bit larger. Is
Yeah.
that still
That's better.
something
Oh,
like
no,
this?
Oh no, go one more. I liked it when it was next one up. There you go.
Okay, so 15, and that, because that's one of the most recent files that we have. And if we go to edit, then we see the actual data arriving, but it's raw data, it's in files, and how can we query that? Maybe we can work with that path. There's now it's date and time related, but if I switch back to my presentation, I have an example where you can use Azure Stream Analytics, which also can output to raw storage, to blob storage, where you can play with that path. The path that is built up can be extended with, for example, the device ID. So each device gets its own folder. And if you play a little bit with the query language, you can actually also work with the module ID and then a slash, and so you can tweak that path. But still, querying files is a challenge. So we need a solution which is more versatile and more powerful than blob storage, but still affordable. And there are a number of ways to do that. So I choose for this solution, for this presentation, Azure Data Explorer as the way to insert a data exploration tool into the whole IoT solution. Azure Data Explorer, as I said already, it's a tool. It's part of the Azure resources made available, and it's a really powerful solution for historical data. Data which is related to time, like telemetry or logging or security events. And it can store a large amount of data in there. It's a tool that is created by Microsoft, by the Microsoft team, and they were so fond of it, the power of it, that they actually made it the heart, the engine of many more Azure solutions. So if you've used application insights or Azure monitoring or Azure Security Center, you will probably recognize some stuff that we will see later on. And because it's a platform as a service solution, we are not interested that much in the architecture, the engine, the how it's working inside. We cannot tweak that much. It's good enough for us to get the data ingested and to work with it. So there are a number of ways to ingest that data, for example, with the SDK or streaming data. And you can put other services behind it. For example, for dashboarding, you can use Power BI or Grafana. Then is the question, and this is from the documentation, is Azure Data Explorer the tool that you need? And for that, well, I want to have a database which does insert only. So I'm adding new telemetry entries. Check. I want to query, and I do not want to change the data, manipulate the data, do updates on the records. Well, I don't need it. It's telemetry over a number of months or years. So that's something that I like to do. It's actually a timeshares database, so it's ordered in time. And I'm allowed to do a platform as a service solution. So I leave it to the Azure cloud to build up that cluster that's behind it. And a more technical question is the data that's coming in, is it really well compressible? And that's a technical thing you can try to figure out for yourself. If you have really small messages, probably you have to look for another solution. But for telemetry in general, this is a perfect tool. So how is Azure Data Explorer working? Well, first of all, data has to come from some source. That can be coming as a event stream with a event hub or an IoT hub, what we will use today. And it can even come as blobs, but blob, when it's created, an event is triggered and that blob is taken, the data from the blob is taken and it's put into the data management. And that's done by the engine. There's an engine that looks at the data that's coming in, and it's fond of batches of data, batching the data, for example, per 1 minute or 1,000 entries or 1 megabyte of data, because then it can analyze the data and try to store it as efficient enough inside the internal database and make it still really fast queryable. So that's what the engine does. Although streaming data is also available, that will cost you some CPU for the cluster, but this is a really nice solution for you if you want to look at the data in real time. The cluster can scale up and scale down, as every cluster should do. And there's a data retention. We cannot really delete data. You can delete complete tables maybe, but deleting data is quite hard. But we have a data retention. we can set to the database, I want to have data in there for only 365 days, 1 year back, or 10 days, or unlimited. That's up to you, what you choose. So the ingestion can be done, in this case, with an IoT hub, and that's what we will do in the next couple of minutes, and we will look at it with some tooling offered by Azure Data Explorer. The data that's coming in is a JSON message, and that message that has to be stored in the cluster. Well, clusters are built up in databases. Databases have tables. Tables have columns. So we need to provide some kind of mapping of fields inside the JSON message to the columns inside the table. But we have a challenge. If we look at the data that we just saw, can I get that back? Yeah. You will see that there are multiple messages coming in. It's a little bit hard to see, but there's data coming from different devices. And they don't look that much the same. So because tables are working with columns, we need to do some extra trick. First, but before we come to that, we first have to have the 3 tables. So we have a table for flight data, one for engine data, and one for cabin data with all the specific columns. But keep in mind, we got one stream with 3 different kinds of device messages. So we have to put them in the 3 separate tables. How do we do that? Well, for that, we use something that's called an update policy. And it's a multi-step solution. And it's not that hard, but you have to imagine data comes into Azure Data Explorer as a stream. And we use an extra table. It's called the source table. And it has 1 column, and it's a dynamic. So instead of an integer string datetime, we just take the whole JSON message which comes in and put it in that single column. How simple is that?
What could possibly go wrong?
Well, you get on one table with all the messages.
Sounds good.
And we already created those 3 extra tables. So what we have to do, we have to write some function, some functionality that will listen to that table. And if there's a new record in there, we pick it up and we put it in the other table. So for example, here I take the flight data and I wrote this function parse flight data, and it will listen to the source table. And if it's the module ID starts with flight, I just pick it and I map it into the flight table, flight data table. So there's 3 functions, each for a different table, flight, cabin, engine, listening to that single source table, and they're picking up the messages that are for them. So let's look how that goes. So I switch over, and here is the Azure Data Explorer on the Azure portal. And there we see that the cluster itself, it's running a really simple compute engine. And there's just 1 instance. If you want to have an SLA, you need to have more. And I can scale up, I can scale out if I want to, and there's a number of databases in there. Well, there's 1 database with a retention time of 365 days. It could be set to unlimited. You can change it afterwards. It's up to you. And the data that is coming in can be queried. And that's here. We see here the database with all the different tables in there, the cabin data with all the cabin related information, the engine data, and we also see that single, let me click on the right spot, we see the source table with just one column in there. And if we look to this piece of logic, we see actually the table being created, create table with the dynamic. Here is the mapping from JSON to that single column. And here I have, for example, the engine data and the function to fill that engine data table. So once this is set up, well, let's try and figure out and do something with the tables. And here I use the query language. So in this case, I do a count on the engine data. So
you zoom in again for us there, Sander, please.
Sorry?
You zoom in again, please.
I'll
let you zoom in.
I will zoom in.
There we go.
Engine data table, and I do a count. And this is already from a number of trials that we did over the last couple of days. So if I look at the common data, there's probably a similar value. But that means that the source table should be really, really big. There's lots of data in there because it's the combination of all. So let's count what's happening there. There's no data in there.
What's that?
How is that? How is that? Well, there's one extra trick that I used. I set the retention time for that specific table to 0 seconds. So if a message comes in, it's directly deleted.
That's useful then.
But the function, the 3 functions are part of a transaction. So just before the record is deleted, all 3 functions are executed, a copy is made, ta-da, 0 records.
That means you're not storing any of the data, so you're not having to worry about any storage accounts or anything else. It's just disappears.
It's
It's just transactional. It's just a way of transacting the data.
I only have 1 copy of each row.
Yeah.
There's only one problem. If new message comes in, I have to add an extra table with an extra function, and then we are good to go. Otherwise, it's gone.
Yeah.
So if we look at the, for example, the engine data from the last 50 minutes, so engine data, then a pipeline where the date time is larger than 50 minutes ago, we actually see the data coming in. And here's the stuff that we see. And for example, we also see that there's a device, plane 1, and if we look at the other one, we see also some data coming in. And actually here we see some plane 1 and 2. There's a C# backup running. So in case everything fails, then we still have that one. So it's working as expected. How's that?
Well, that's ruined it. Yeah, thanks.
It's Sander's fault.
And this is, and I go back to my slides and I show you that we are using the Custo query language. And Custo, well, that's a pun from the team. I believe it's the working title of Azure Data Explorer, and it's derived from Jacques Cousteau, a French deep sea diver and explorer. And well, he went to the sea and explored everything over there. Wrote some books. So, well, we are exploring data with the query language. So that's cool. And we've seen some the Cousteau query language already with the count and with the where part. Is that a new language for us? Probably it is. Although for those using Azure Azure Log Analytics or application insights, if you drill down a little bit, you will end up in something that looks like the tables with the query language. So it's worth the time to invest some time in there to
on that Custo language. How different is it to a language others? Is it SQL-like? Is it like JSON, JavaScript? Is it like?
No.
Give people
well, of course, it's a query language like any data exploring language, but this is more like a funnel. You start with a amount of data, and then with a pipe sign, you say, I want to have a subset, and from there, I want to have a subset, and from there, I want to have the representation. So I have the actual columns, and from there, I want to have set the order, and then I maybe want to have in between somewhere the top 10 or something like that. So if you're aware of exploring data, this is a really interesting solution for you. So with this, you can explore an ocean of data.
Oh no! I thought you were going to bring data lake into it then.
I think the same. Yeah.
So here are some examples to show how it works. The count, we have seen that already. There's this filter with the where clause. I take the top 10 order based on the ordering of the datetime UTC, and then I take a number of columns. Then there's, well, why not dig into the examples by some actually Excel examples. So let me figure out the right tab. Well, here we have the Kaplan data, and I just take 20 rows. Here it says, and it's just taking random rows. And I actually get all information about CPU usage, so I know if this is an efficient query or not. Then I take something similar with a where clause. The cabin humidity has to be lower than 45. The percentage of 45%, and I want to have the last 10 rows in there. And as you can see, well, the cabin humidity is quite low. I think they are selling drinks instead of serving it. So that's well. Now
if you think about it, though, most aircrafts, the cabin humidity is a lot lower than what you're used to down here, because other than the 787, things like the 747, the 777, the Airbus A320, the air you breathe has been squashed and heated up by the engines, and then it's dissipated out into the cabin. So when it's heated up and squashed by the engine, and that heat burns off all the moisture, which is why it's quite a dry cabin atmosphere.
It's always cold as well. It's always cold air. At
least,
least,
that's because we up the front, the cabin crew are really hot, so we turn the temperature down for them. But on the 787, it's really moist there because they've got a system on there that takes water from the water tanks and puts it into the cabin atmosphere to make it really moist.
Oh, I didn't know that.
So
Okay.
Clever technology from Boeing. But you've detected that this is probably a 777 rather than 787.
It's the flight to the sun, I think, and they want to squeeze every dollar out of it. Well, we've seen the information shown as tables, which is quite fun, but why not do something with a chart? And here we see that I'm using a time chart. I believe I can make it a little bit more interesting for us if I just take the line chart. Well, whatever. There are a number of charts that I can use. Bar chart, column chart, well, you name it, it's probably there. So I can glance at the data coming in from a chart, a graphical representation. And so this is a really interesting way to work with the data. But keep in mind, we had something with the endurance of the engine, which is the amount of hours that we can fly based on the amount of fuel that we have. But we're also interested in the flight time left of the airplane, and that's in the flight data. So can I combine that? Can I check out and compare it? Well, I could.
Do you have enough fuel to get to destination?
Yeah.
Are you going to run out before you get there?
Yeah, that would be
good reason. Yeah,
it would be nice to know.
But the data's on two different devices. You've got one coming from the Meta and one coming from the Pico. So,
yeah, but there are two streams. I have two columns, so I can try to compare both columns. And there's a join. There's inner join, outer join.
Just like SQL.
Yeah.
It's in there. The query language is quite evolved. It's already there many years, but it was a little bit hidden for me, maybe for you also. But So let's try to find out if we find similar measurements on the same date and time and device. So let's see, and no rows to show.
Again? Have you deleted all the rows again?
No, well, the data is there, but those are 3 different devices, 3 different clocks, 3 different timelines. So the possibility that they actually at the same millisecond, because this is daytime UTC, so it's the correct.
You got the 3 decimal places on there. Is that what it is?
Yeah,
Right,
it's in time, in a timeline. It's not always on the same moment. So can we get away with that? Can we work around this? And yes, we can. If I go a little bit less big, then I can go to the next tab. And because we can use something like time windows.
Oh, like we spoke about Stream Analytics earlier.
Yeah. There's a similar solution in Azure Data Explorer. So with this sample, which I prepared already, I'm comparing the engine data with the flight data for a certain plane. And I look at measurements within 0.4 seconds. And so if they are nearby, then they are seen as 1.
You zoom back in again after you zoom back out. It looks a bit
I will.
there we go. I know you might not be able to get all of it on the screen, but that's fine. That's fine.
So we have the delta of time windowing that I use. I have the device. I'm using something with the engine data combined with the flight data. And in the end, I want to have the device, the date time from the engine, the date time from the flight, and I want to compare the fuel on board with the flight time hours. Well, it should be in there. So let's kick this off. And it's running, and I have some information, and I can see for this plane 1, the endurance is something like almost 12 hours right now, and we still have to fly for 4 hours.
Somebody's overfueled the plane. That's bad.
You're going to use a lot of fuel there to carry that extra fuel.
Exactly.
Yeah, 10%.
Oh,
So
expensive mistake.
you got this from the simulator, so maybe.
It's your fault.
I overfueled the aircraft. Yeah.
What can I say? The query language is quite powerful. I think you agree with that. But this query language is not that handy for a person like you and me, maybe, because that's more for a data scientist. I want to have something with charts.
Nice.
And actually, if we go to Azure Data Explorer, there is a possibility to build up dashboards. And here I prepared a dashboard already. And this is from the last hour, and I go for plane 1 and give it a few seconds. And we see, well, actually with the cabin data, you see that the outside temperature dropped suddenly because we left off more than an hour ago. And we also see from the last hour here, because it just updated, that the flight path in a map, and you see there's something happening with the data, the vertical flight.
Vertical speed, yeah.
Vertical speed, that's the one.
In feet per minute, yeah.
Free speed.
You're the expert.
Yes.
You tell me. So you see that there's something happening during that flight. So
you'll see spikes because you'll level off at a certain altitude, and air traffic control then asks you to climb to the next altitude, and you climb up. And then when you get the other end, obviously you'll step and descend down. So you see steps going up and steps coming down.
Well, you see it also with the engine data. If you compare it with the vertical speed, that's happening. So and this is really nice. And I'm allowed, or I'm able to add these filters. I can then add 1 or more charts in there. So if I go to editing, we can look into that. If I go to this chart, we see actually that I'm looking at the engine data, and I choose a line chart, and I'm working with a number of parameters, the device ID and the start time and the end time, so I can squeeze it in if I want to. And how do I get those? Because I partially built the parameters myself. The start time and end time, those I get for free. But I added the device ID because there are devices in there. That's the airplanes, and I called it device ID, and it's working with the underscore device ID. And I got it actually from a union by taking all the distinct device IDs from the 3 different tables and came with a unique list of device IDs. So this is, well, pretty interesting for more of a IT developer like me. So if I go back to the presentation, the interesting part is that this part is controlled by Azure Active Directory, so I can arrange it to certain people and look at it. But there's one drawback. This things that maybe last year we've seen time series inside, which is a similar tool, not that much powerful as this, but it had that really nice interface with sliders and all kinds of visual tooling. Well, time series inside will stop somewhere in the future in a couple of years. And Microsoft is already saying Azure Data Explorer will be the successor. It's more powerful, and I can really urge you to look into Azure Data Explorer and try to think about the official migration. But that visual components, that visual interface, it's not there officially in Azure Data Explorer. You have to work with the dashboards and you have to work with the queries. But Microsoft released Custo Trender. It's on GitHub. It's a combination of the visual tooling with the widgets made available in JavaScript, so you can start building your own user interface on top of Azure Data Explorer. So if you're interested in Azure Data Explorer, but you're still fond of that user interface, try to find some programmers and start working on a custom dashboard on top of it. There's not a one-on-one migration, but it's a start. So with that, we've seen that Azure Data Explorer can help us with that cold path and also with the warm path, with the dashboarding. With the Custo query language, we can even help a data scientist. There's dashboards in there, which is really, really nice. And with Custo Trender, we have a time series inside migration. So with that, Azure Data Explorer is worth the time to explore it, the tool itself.
Oh,
Pun was intended.
We've had less of puns than I would have thought actually this whole time. But.
And so there's lots of stuff in there. There's documentation. There are learning modules on MS Learn. There's a free ADX cluster. It works with upload and download, upload from data, not with streaming data, but well, you get almost everything for free. There are plural sites courses made available, and they are of excellent quality. So look into that. And there's also a Custo Detective Challenge, where you start doing detective stuff. You get challenges, and you have to work with data sets. I don't give it away. It's fun, and it's really interesting. And last but not least, I wrote a couple of blogs about the migration or the integration with IoT Hub and Azure Data Explorer. So, yeah.
Very good.
Well done.
Excellent. I mean,
lots of fun stuff there.
By my reckoning, we're about, what, 2/3 of the way through our flight?
Yeah,
And
where
obviously
are we
today.
now?
So
if we ask,
let's have a look. Oh, look, I think maybe it's at 2/3, more than 2/3 if you ask me.
Yeah, that's about right. About 2/3. Yeah, we've got across the backhanded a bit.
Yeah, exactly.
Yeah, I nearly said it then.
Yeah.
Careful.
Careful. We're slightly, I mean, our timings are relatively flexible, so please don't rely too much on the agenda. But actually, Sander has stolen time from his own session by overrunning on his own session. So we're moving up next. We've got Sander again talking about Azure Digital Twins. And then after that, we'll move on and John Lunn will be talking about Power BI. And then after that, we'll come back for a Q&A session. We've made sure to leave plenty of time at the end of this so that we can answer all your questions. And I know there are some awesome questions in there. And apologies that we've not got to them already, but we've got so much to pack in that we wanted to make sure we got the content out and dedicate some time to those at the end. So do keep asking your questions on YouTube and in Teams, and use the hashtag TechDays to interact on social media as well.
This bit and the Power BI bit, I think the bits I think are
this bit's cool.
Look really cool.
If you're thinking of leaving at this point, do not. This is where it starts
Don't even
getting
go
really
to the
cool.
toilet.
Yeah, exactly. When Sander showed us this, when he'd made it, it was like, oh, that's
wow,
cool. So not to pick him up too much, we'll switch across and Sander again. The Sander show.
Okay. This is all about Azure Digital Twins. Yeah. Here it starts. It starts to get really fun. So before we dig into that technical part, let's think about a IoT solution. There are multiple users of an IoT solution. There's the stakeholder. He or she is paying for everything. So probably he's interested or she is interested in costs, earnings, OEE, KPIs. So that's how that person is looking at the IoT solution. Then we have the engineers and the IoT developers. Well, those are interested in is the solution still working? Is the data coming in? Are there gaps in the transmission of the data? They are not really interested into the data itself. Maybe the engineer at some point, but it's more the data scientist who's really digging into that raw data. So he also is looking at that stuff. And then we have the line manager. The line manager is responsible for the whole solution. He has to make decisions, but probably he's not that well informed in the technical complications of the whole solution. So all four personas need another dashboard. So if we look at the stakeholder, well, probably we will, John will show it with Power BI, something like that. That's for the enterprise. So that's what a stakeholder wants to see. Then we have the engineers and the IoT developer, and those are more interested in the dashboarding that we've seen in Azure Data Explorer. Then we have the data scientist, and the data scientist is really interested in that raw data. So it will use some big data tooling or Azure Data Explorer. But what do we offer a line manager? A line manager needs something simple to understand, not that technical, and it should be clear. So the decisions can be made, and maybe it even helps with making decisions. Some extra alerts are put in there. So something simple to understand, well, that looks like a model. Because we all have learned at school that a model is a simplified way to look at the real world. So a model, yeah, that's something that we know already in the IoT world. And that's called a digital twin. A digital twin is a digital representation of something that's there in the world. It's either a physical device or a sensor, or it's a location where those sensors are. And it can even be a business process where the data is flowing through, or a person's, people generating data, or people wearing sensors. It can all be something like that. And that's called an environment if we all put it together. And we are in luck because we want to add some digital twin solution inside the solution that we already have. We have the raw data from the sensors, we have the cold storage, we have the warm path, we have the alerting, but what about digital twins? And actually Microsoft provides in Azure Digital Twins. And that's an environment where the real world can be modeled and simplified. And because it's a model and it's not actually the real thing, but something that looks like it, we can add extra stuff to it, like extra rules or historical data or something that we predict for in the future. So that's how we work with that environment. And once we have that single environment, why not connect it with other environments? Once you have a building, why not connect it to extra more buildings or with the transportation around it? Well, how does Azure Digital Twins work? It all starts with an environment with a graph of twins. The twins are living in there, they're related with each other, there's a parent-child relationship, and we work with that environment using the SDK. We can program against the environment. It's living there, it's running, and it shows the current situation, and we can connect data coming from an IoT hub or from other sources, and we can react on changes within the environment. If a twin changes, we can check the events which are generated, and we can even start interacting with other environments, for example, some 3D representation of that twin environment. So let's look at our solution. First, we have to think about the twins, and twins are related to models, so let's figure out the models. Well, at this moment, we are working with an aircraft, and it has a number of devices, and an aircraft is part of an airliner. So that means that we are working with something like 5 models: airliner, airplane, and the 3 different sensors. And these are related with each other. So how do we model that? Well, with a model language. And for the Azure Digital Twins, the digital twin modeling language is supported. And if we look at the example that I've put in here, it's the airliner. It's the most simple example from the whole solution that we will see soon. An airliner has a company name and an abbreviation, and it has a relationship with an airplane. And as you can see, the whole airliner model has a unique identification and a version number, version 3 in this case. And the relationship is also related with the description of an airplane, also with a unique model. Once we have the models, we can start to think about adding something extra to it. Do we still know the endurance? That's a calculation which is not in the original sensor data, but we can add it to the model of an engine.
So you're just to add to that, you're enriching the data, aren't you? You're kind of adding stuff in that you've calculated over here to enrich that data and make it mean more to the person that's viewing the data.
And in this case, it's on the level of the engine itself,
Yeah.
on the sensor level. The same goes for the anomaly detection with the pressure ratio. That's a second stream of data, but we can add it to the same engine. And then there's on a higher level, if we compare the endurance with the flight data, which are 2 siblings, we can give an alert on airplane level for the consumption alert. So how do we interact? How we work with those models? Well, models are written in JSON, but luckily we have this this Explorer made available where we can do basic interaction with the environment. So let's move over and look at the environment itself. Well, the environment itself, it's running in Azure, and there's not that much that we can do with it. It's running there, and we have to interact with it. Luckily, there's this button with the Digital Twin Explorer. It's in preview, but it's working well, and here it is. This is the environment, and as you can see on the left side, we actually see the different models which are uploaded. For example, that airliner, if I look at the model, we see the company name and the abbreviation and the relationship. So if I close this and I go to the airplane, I can see that there is a plane type, year of build, and I see that there are a number of relationships with flight data, engine data, and cabin data. Once I have the models, uploaded the models, I can create twins. Well, a twin has just a name, and that's the representation of something in the world. Probably the name will give away what the actual thing is that's living in the world. But in our case, I already uploaded a number of them, and with this query language, I can actually look into the already uploaded twins. There's an airliner, there are 2 airplanes, there are a number of sensors underneath it, and if I go, for example, to the cabin data, we will see that there are a number of values put in there. So that's how the current situation looks like. I'm looking at the current situation of what's in there in that environment. And I can actually, and I go back to my slide, I can try to figure out what's happening inside my environment by using that query language. So I can, with an SDK query, and for example, I can say, give me all the twins with a certain call sign, or which are representing a certain kind of model. And if I go back to the Explorer, we can actually see it because I uploaded a number of them. Here is the query for a fuel alert, and let's try to figure out if there's currently a twin which has a fuel alert. No, it has not. So let's, just to make sure, if I do false, then I get the 2 planes which are not having a fuel alert, which is good.
Yeah, we already know that Cliff overfueled it, so I think we're all right.
We should be good.
I can also look at parent-child relationships. In this case, I'm interested in the cabin data and the parent. And it's for a certain airplane. And there I see the cabin data and the relationship even between the cabin and that airplane. And last but not least, if I take this one, I give me all the twins which are currently implementing a certain model, because twins can change over time, or models can change over time. So the query language is quite extensive, and it takes some time to get around it. But well, this is a graph, so again, there is a language designed to work with that digital twin graph, and that will give us the current situation of what's happening. And we can traverse through the graph to look at parents, and from parents we can go to siblings. But it's still the current situation. How do we get the data from the sensors sent towards the environment? It's done with SDKs, and SDKs, they are triggered using Azure functions. And as we see here in this example, I wrote a number of Azure functions, and they all have a different meaning. It's a little bit overdone maybe, but well, I wanted to show the full picture, because there's multiple ways to interact with an environment. First of all, there's the ingestion of the data from the IoT hub. That's an Azure function. There's a Azure function for ingesting data from the anomalies, because we want to have that anomaly from the stream analytics job sent to the digital twin. And that will probably change the twin, or it will, telemetry from multiple sources will fly through the environment and they can pick up. So there's two extra Azure functions, one for telemetry flying through the environment. Now it's one source. And if twins are changed, the properties are changed, we will see that it can trigger these extra Azure functions. So how do I use this? Well, I use this to implement business rules, because there are a number of business rules in there, which we have seen, but we have not seen them directly. But here I will show them for you. First of all, the flight time left, it was in seconds, and I want to have it in hours. We've seen that with the Azure Data Explorer, maybe you looked at it. That's something that I put in the ingestion. It's simple, just put it in the right property and fly through. Then we have the endurance, which is something that has to be changed on the same engine twin. So I could have done it on the ingestion level, but I find it that much important, so I gave it its unique place in this Azure function. Then there's the fuel consumption alert. Once the endurance change of the engine, I can traverse to the parent, and from the parent to the flight sensor, and I can compare it and give an alert on airplane level. And last but not least, there's the anomaly detection, which is also an Azure function. So with that, we can show what's happening or work with the twin, and we can actually see, if I go back to the show all, and I can see that there's actually something happening. For example, the plane itself, it has that Boolean, the fuel consumption alert, which can be set true or false by the events behind it, by the Azure functions. And if we look at the, let's see, the cabin data, we see a counter, it's 2537. And if I go back and then you see that it is another counter. So this is live data. This is coming from your devices. But is this the thing that a line manager wants to see?
It looks a bit engineering.
Yeah.
Can you make it a bit nicer, please?
Yeah. Probably
there's something you could do.
Something shiny.
Yeah, why not?
Something which is more like a 3D model.
Yeah, maybe.
Something more like this.
That looks good.
This
We like
looks
that
good.
sound.
Yeah.
And actually, this is part of Azure Digital Twins. On top of that graph, which is pretty straightforward, we can put a visual layer with a 3D model. And that is just a GLB file. You could build it with Paint 3D if you want to. And it gives you the opportunity to work with that model and to give icons. If there's an alert on a certain part of that model, we can change colors of parts of the model, and we can even add a legend. So you can click on it and you get all the information around it. And there's only one drawback. It does not change shape. It's not changing shape based on what's happening. You probably have to use something like a Unity, work with Blender or whatever to have something which change in shape like a robot arm, if you want to have that. But let's see what it can, and it's really, really nice. I already uploaded a, let me go back. I uploaded a GLB file. I gave it on a globe a fixed location. So if I go to the globe view, we can see that we have 3 different devices. And if I look at the device, you can see that I actually have a 3D model in there. Let's open it a little bit. And I can select and combine multiple parts of a model. And for example, here's the engine part. And I can say, okay, I want to have multiple behavior on that one. For example, I want to have a legend. Here's the legend. I can even put in links to documentation if I want to.
That's so cool looking. I love that.
Yeah, that is that's certainly something that a line manager, or even just on the wall of the ops room, you know, is the sort of thing that people want to see, isn't it? As a visual representative, because a picture speaks 1,000 words. You know, if it turns red, something's bad. You know,
correct.
Yeah.
And this is just a legend, but if I put next to it a alert with a certain icon, if there's something popping up, like the fuel consumption alert. And I can also work with a certain status where I give a whole part of the airplane or a certain color. So for example, here I look at the cabin altitude, and if it's at a certain height, I can give it a certain color. But keep in mind, this looks a little bit like a business rule. So probably you have to want to have it done in a different way. But okay, this is how it's designed. This is the 3D Scenes Studio. How does it work in real life? And that's how it's working here. We are not in luck. There are no alerts at this moment.
The passengers are in luck though.
But
they're all right.
I can select the legend, and I can even go to a certain documentation page. And it is just an Azure function with some stuff. But you can see I know what I'm talking about. For that certain twin, I can give a certain documentation page.
Something's just turned yellow there. So
Yeah. So
alert is
that's there. That's because if I go, the flight time left status has changed.
It's telling you something.
So there's some stuff in there. I could probably, and that's just something which was not rehearsed. I go to this one.
Well, we
and
rehearsed
actually,
something, did we?
don't know when that happens.
Oh, there it is. We see that there's a alert. The engine temperature is too high.
Ooh, okay.
That's you have to check that, Cliff. So, so this is a really nice representation of a twin. So with that, we have built a complete digital twin environment, and it's a lot of work. Once you have figured out how the Azure functions work, you're good to go. And there's luckily lots of documentation available. There's an extended training on MS Learn, and I also wrote some posts about it, how to work with that 3D Studio. So we have digital twins, we have a visual representation.
Love it.
Really cool. Yeah. That is so cool, and the sort of thing that, you know, any kind of line manager or kind of that area of the business is going to want a live representation of what's going on in the real world, like the map view of where the device is around the globe. That sort of thing is very cool. Coming back to our chart though, it looks like we're nearing the end of our flight, which means we need to know how this was built. I think we do.
So we've got some laptop switching to do, some people to move around. So at this point, we've got a little note from our sponsors. Yes. So.
Oh, hey there. I'm Alex Karim. I'm the Metaverse lead here at Microsoft UK. I'm a massive advocate of developer communities. You've obviously just seen Flight into IoT 2, a really great MVP-led learning path. If you want to get started with IoT, there's obviously courses like Flight into IoT that you can check out. At a global level, we have the IoT show run by Olivier Bloch. Scott Hanselman does loads of great content, but if there was one thing I was going to leave you with, it was 30 days to learn it. I'd highly recommend you go check that out. If you complete the learning path, by the way, you get a 50% off voucher for a Microsoft certification. So not only boosting your CV, but also boosting your learning at the same time. So thank you very much and enjoy. See you later.
Awesome. Yeah, I mean, 30 days to learn it is a fantastic. You definitely go ahead and check that out, and get yourself on that IoT certification journey. So actually, we've reached the very final session. We've got some Q&A after this, but we've got if we flick back, we've actually got the Power BI flight tracker that we've been flicking to every now and again, and we can see that we're heading towards landing in Seattle. We're not far off, in fact. But we'll now introduce John Lunn, and John has built up this Power BI dashboard, and he's going to describe how that all works and how you pulled it together.
How you doing, guys? Nice to be here.
Good, yeah.
What an awesome show, eh? I mean, well done, Sander. That's absolutely amazing work. It's great.
Again, Sander is, I mean, we cannot thank Sander enough, because a lot, and as you've seen, because he's done 2.5 sessions, really. So we cannot thank him enough for the amount of work he's done. And while we're on that topic, everybody that's here, and what you can't see is there's a whole heap of people behind the scenes that have made today work. We've just stood in front of the camera for 3 hours, but everybody has been here all day doing so much work. So we cannot thank you enough. Thank you.
Yeah, well done.
And thankfully, the tech has all worked. All the devices are kept going. It's working. The little blinky lights here and there.
Just lucky nobody was filming before the sessions. Yeah.
Oh yeah, but 2 minutes before the sessions, it was chaos.
It's definitely Swan-like.
Yeah, absolutely.
Yeah.
So yeah.
Definitely.
So yeah, guys, look, it's really it's a pleasure to be here. Great to see you again in person. Obviously, it's great to
3D
actually turn up. Yeah, 3D people, not just digital twins, eh?
Yes.
So look, everybody watching, thanks for sticking around. It's been a great couple of hours now. I mean, my part of this now is really try and kind of take it to that level of what else can we do. We've been through some awesome stuff now over the last couple of hours looking at devices. How does meshing come from devices into IoT Hub in Azure? How can we manipulate that data? What have we done with it with Stream Analytics? And we've moved right the way through. My part really is to look at, we've been into Splice in the session with that flight map. We've seen that we can do similar things with Azure Data Explorer, with dashboards, but really this is just about kind of overlaying what else can we do with that data? Where else can we take it? So that's my part. So yeah, hi everybody, thanks for watching. I'm John Lunn. Up until a couple of weeks ago, I was an Azure MVP, but I'm now a Microsoft full-time employee. So as was mentioned a few hours ago. So yeah, I've just started with Microsoft as an Azure specialist in the stew. So hello, that's me. So to kind of set the scene, we're going to be taking a look really at Power BI, but just so everybody's kind of aware, Power BI fits into essentially the go on. Sorry.
So just if we switch to Cliff's screen share because it's gone against the grain. There we go. Yeah. So all our fault.
There we go. So there we go. So you can see my picture. There's me and there's me there. So there we go. Everybody can see.
Yeah. You can carry on now.
So yeah, I mean, we're going to look at Power BI specifically, but just to set the scene, I'll talk a little bit in a second about what Power BI actually is, but it fits within the Microsoft Power Platform stack of products, essentially. You might have heard of this low-code, no-code, and this automation. I think you mentioned earlier around, obviously logic apps and the fact that we've got Microsoft Flow. So really, Microsoft Power BI is one of those utilities that we can use to kind of manipulate and visualize data in a certain way. So as with everything, there's always a lot of tooling that we can use with kind of digging into data. Sander quite brilliantly demonstrated the Data Explorer. It might be that we might want to use other tools for other audiences or other stakeholders within our business, as was described earlier on. And this is really where we start to introduce Power BI. So essentially, Power BI is effectively the entry point to when we want to start on our analytics journey. We can try and really simplify the visualization and the usage of that data and share those dashboards or reports out to our end users so that people can really get a sense to reduce that complexity that you may have seen in some of those. And I think, Pete, you mentioned, obviously Azure Data Explorer and some of the digital twins data was probably geared up for more the data scientists or the engineers in a business. Let's take a step and maybe we'll frame that Power BI can be used for other business stakeholders. Yeah. Maybe people that just need to see that subset as simplified.
My wife uses Power BI and all the flow tools actually. She works in accounts. So they take the data from all their Excel spreadsheets and put it into a Power BI dashboard.
You're allowed to say where she works, by the way.
Heathrow. There you go.
Let's keep it topical, yeah?
Yeah, it keeps it topical, yeah. We're an aviation family. But it gives them, instead of a spreadsheet with umpteen million tabs and all that stuff going on, it's one kind of dashboard, and it's so powerful.
And look, it's part of this Power Platform product set, which is essentially, it's available to end users if you subscribe to Microsoft 365 services within your business. You can start to use some of this and explore some of that data. So I'm going to touch on really, just to recap what Power BI is first and foremost. The idea is we can connect to our data wherever we are in the world, wherever that data is in the world. Really powerful utility to do that in that kind of easy to use fashion. We can dig into that at a certain level of data. We can create our data models and our relationships between data tables and other databases if we need to. So we can prepare that data. So we can do a little bit of that ETL, that transform data. We can load it into a data storage. We can do some transform, and we can manipulate it all within Power BI. The other thing is we can delve in, using visualizations, do some pretty advanced analytics, at that level. And it's all about, enabling people to do this for themselves at their desktops. And as it says there, it's the familiarity of that Office product suite, so we can use Power BI for that. And essentially, we can look at deepening our data insights with AI-driven augmented analytics. Now, AI is getting into every product at the moment. Wherever we turn, we can understand that AI plays a part to some extent. We can create interactive, as you mentioned just then, Cliff. We're starting to see that. Well, we've seen for a long time actually that Power BI is used across business in multiple different departments for different purposes. So essentially, that's what Power BI is all about. It's being able to author reporting, dashboarding for anybody, no matter what area of the business you sit in, not necessarily just a technical view of something. So how does that relate to the flight into IoT, I guess, is probably the question. So yeah, you've seen we flashed up that little graphic throughout the sessions today. And really all I'm going to do is use this session now to show how we can start to build up some of these reports and dashboards. So flicking on over, we're going to look at create an environment. So what we're going to run through now in the next sort of 15 minutes or so. First off, we're going to talk about what Power BI workspaces are. I'm going to show you what they are, what kind of things they hold in there. So there's a little screenshot. We'll be delving into that in a second. We're going to return to the Stream Analytics job that was described earlier on that Sander went through to show you all those different output jobs and show how that Power BI data set is actually populated. So that little yellow area at the bottom is effectively the bit that we're going to be focusing on in this part of the session. We're going to explore some visualization objects within the Power BI desktop product. And how do we configure some of those things? How can we use some of those visualizations? Finally, once we've configured a report, we're going to understand what does it mean to publish that report up to the Power BI workspace and use it online. So that's what we're going to cover off. I think I'm going to now flick over to my other screen, which is here. So this is it. So first thing is, Sander did a brilliant job of explaining this earlier on. I'm going to keep it fairly lightweight at the moment because the detail has been kind of delved into. But essentially, we've got this Stream Analytics job. But if you remember our data from our sensors that are sat on the desk there with Pete and Cliff, that data is being fed up into the IoT Hub at the moment. The IoT Hub is then onward forwarding that data through subscribers into many things, essentially. Part of the Stream Analytics job that it's where the data is coming from IoT Hub into Stream Analytics. We've got this Stream Analytics query that we saw earlier on that is then subsetting that data out to various different outputs. Now, we could use the data from one of those outputs. As it happens, within Stream Analytics, within Azure, we can actually create a brand new output, as you can see on the screen here, that you can essentially just hook straight in to a Power BI workspace. So when a workspace in Power BI is just a place that we can create to logically contain data sets, reports, dashboards, that kind of thing. So within the Stream Analytics job, we can actually create an output. And for the purposes of time, this has been recreated. And if we look at the properties on this dashboard, this output, we're connecting to an alias essentially that is set within my Power BI workspace, which I'll flick over to in a second. And essentially all we're doing is we're authenticating it. And it's quite an important point to note here is that we can authenticate with a completely, separate tenant, separate ID, completely different Azure AD. We don't have to authenticate to that workspace with the same credentials that we are using to manage our Azure environment, which in itself is quite powerful, because we can have our data anywhere. Back to that point, authoring reports and dashboards from anywhere for anybody. So that's essentially what we're doing. We've got our Power BI output within our Stream Analytics job. And somewhere in here, it's quite a long query now. I think Sander mentioned earlier on that we probably are doing some quite quirky things in here. But you can see that all I've done, so there's that little comment there, the flight data set is being sent directly to Power BI. So I've not done anything too tricky, and I've tried to keep this simple. I'm just having a selfie with Pete and Cliff. Sorry, like they distracted me. So I tried to keep it pretty simple in the sense that for this demonstration, I've just taken the flight data, mainly because I'm not a SQL guy, and I didn't really fancy sat there, but doing all these in and outer joins. You can spend the time, obviously, and you can do that, but I thought for the sake of keeping things simple, I will just get the data from our flight device, which I think was the first device there, Pete, wasn't it? The Pico. So that data, remember everybody, this data is going in real time throughout this session. I mean, I don't think we've kind of stressed that enough. We said it earlier, but this is real time data, and we're actually using the tools as that data is coming in, which is quite a powerful thing. So what we're doing is we're taking the input from the IoT Hub, is coming through IoT Hub into our Stream Analytics job, and that data then is being sent onwards to our Power BI workspace. So let's have a little look at our Power BI workspace, if I can ever remember where I put it. So yeah, see, I knew I'd forget where I put it. Bear with.
You're going to blame me for this now, aren't you?
Well, you set these things up earlier on. There it is. It's hiding there, and of course, it's logged me out in good fashion. Ignore the.
We're nearly there, though. You can see we're just coming down towards Vancouver.
We are. We're not far away now, and it's perfectly timed, I think, isn't it?
Yeah, we've done well.
Almost. So, look, this is our Power BI space online. So I'm logged in online, like I say, with an account from a completely separate tenant, so that we can understand. It doesn't matter. It's all about authenticating.
So as that's online, that means anyone globally could log into that space, as long as they're within that tenant, can log in and see that Power BI dashboard.
Not necessarily. You can see there's a little share button at the top there, Cliff. Yeah. So we can literally put whoever we need to give access to that access and share that out. Okay. Hence, we can share this dashboard or this report out with many people. And I'll talk through that briefly in a second. Now we'll have a little look. So yeah, as I said, first and foremost, typically speaking, this is your Power BI view when you log in online. Yes, there are some licensing implications, and you need certain licenses, of which we're not going to get into in this session. So basically, workspace, first and foremost, is that we're going to set up an area that is a logical container that's there to contain the stuff that we want to use within Power BI. So you'll see I've created a workspace. They're called Tech Days 2022. And you'll see I've got a few things in there. Now, I do actually happen to have a data set for the engine data and a data set for the cabin data. But like I say, when I was preparing this and thinking about how to kind of present this, I thought, well, I'll just roll all that back and try and keep it simple. So for now, this data set has really come from that Stream Analytics job. As soon as we've created that authentication into our Power BI workspace, we've presented that workspace as the location we want to store our data. The first thing that we can do is create that data set, and it does it automatically. So as soon as that data comes from the Stream Analytics job, we get a data set presented to us, which is great. Now, to be honest, there's not a great deal you can do through the workspace in terms of interrogating that data. We need to do something else now. So what we would do then is we'd refer over to our Power BI desktop. So Power BI desktop, if you like, is a downloadable part of, not sure if it's part of the Office platform, but it's a downloadable executable that you install on a local machine. And you use it to create and author reports and such. Once you've done that on your local machine, you save it off as a file type, and you can then push that into your Power BI workspace. So that's what I want to do. I said we'd take a look at some of the visualizations. So you can see this is the report that we're using that has been flashed up throughout the course of this session. And we can interrogate this report. We can kind of click on any part of this flight and kind of just start to see some of the information that, remember, has been streamed from those IoT devices through our IoT Hub, stream analytics into our Power BI data set. So we can start to interrogate it in a few quite clever ways. So the first thing to think is once we've made that connection, when we create a report, we click on Get Data and we literally log into our account. We can see that we've got that data set created there. We can hook into that. The first thing we see is, as per any kind of data integration with lots of Office products, you'll see that now we've got access to all of those columns, those data types, that data that has come from the JSON formatted files right the way through all the system. It's presented to us in a flight data table there on the right-hand side of Power BI, and we can start to pick and choose what do we actually want to show in our reports. So as you can see, I've kind of picked a few elements, but I'm going to go over and go, let's see how far I get now before I crash and burn. No pun intended there, obviously.
Oh dear.
That was a bad phrase, I know. But so in a sense, I've just created a new page here. I'm not going to change. I mean, I could change. We're using a different thing for the screen share, but just to show like how we brought some of this information in, let's just try and recreate that map element for a second. So the first thing that we can do is that we can expand this visualizations area, and we can see that we've got a lot of integrated options available to us, like line charts, bar charts, pie charts, all that good stuff. And you can see that we've got one there, a little map element. It's really simple. We can click on that map element, and we get that tile presented in our report. Now, with the visualization, we can also see down the side that once we highlight that map element, that tile that we've got there, we can start to populate that map component, that visualization, with some information. So it's really simple because the flight data that we're getting from the flight module actually contains our latitude and longitude, which, to be honest with you, is probably good if we want to know where that flight is on our path. So we can literally grab the latitude, drag it over here into the latitude box, drag the longitude, drag it into there, and lo and behold, we can start to see some stuff happening on our visualization. Now, it's up to us now. How do we want that look? How do we want to format it on that page? We can literally drag and drop, make that map bigger, smaller, whatever it might be. We can do a lot of things with it. And hopefully you'll agree that that was done in minutes as opposed to anything else. There was no real coding that I had to do there. It was all integrated straight in with that connector, dragging a few components from the fields onto our visualization. The next thing that we can look at is that you can see it's all blue. So, okay, how do we start to make that visualization look a little bit more appropriate? Maybe we want to do things based on certain color types and whatever's going on within our data. So straight away, we've got the ability now to kind of format that visual. We can do a few things. We can start to look at some of these options. We can change the map style. And these are all built in to the actual visualizations within Power BI. And by the way, there are lots of other third-party visualizations. Excuse me. And if you are a little bit more advanced in terms of developing these, you can develop your own visualizations as well. So there's lots of things that we can do here. But we can change the map settings. So the first thing is maybe, as you saw in the map earlier, if I flick back to this flight data, you'll see that I kind of color-coded that. I don't know whether you can see it or not, but if I zoom in a little bit, when we took off, oh, zoom in too much there. When we took off a little earlier on today, we were starting at red, we were coming through the yellow and amber stages, and we went up to green. So essentially, what does that mean? Well, just for the sake of showing something on the screen, red means we're kind of on ground level, coming up to a certain height. Orange means we're changing height, and then green means we're at effectively potentially a safe altitude. So if we see that green path, we can comfortably say, yeah, we're happy the flight is currently at a safe altitude. So how do we show that? So if we flick back over to the one that we're going through at the minute, we can click on the format visualization. If I actually select the visualization, click on format, and we got this bubbles. The bubbles are the little dots that appear. We can change the size of the dots. I mean, these dots will probably change there on the screen as I change that slider. We can make them as big or as little as we like. When we look at colors, we can leave it the default blue. We've got the option of clicking on this function, and we can start to say, okay, so what will this color be based on? So we don't necessarily want it to be on the sum of altitude. We just want it to be on a unique value. So maybe we'll change that to something like minimum. So it'll just pick a single value. Maybe we want to introduce a middle color. We want to make the colors something a little bit more appropriate. So red being the lowest value, green being the highest value, if I could find green there. But the idea is, hopefully, as you can see, I'm working through this. There's no real difficulty here. It's all pretty quick and fairly straightforward with how we do it. I mean, if I just click OK on that, we could put in our custom values if we wanted to say, you know, anything up to 100 feet is, anything in red would be up to 100 feet, anything over 100 up to 15,000. You know, you've got the idea that you can start to layer in the actual logic of why you might want to color code things. I'm just going to click OK there, and hopefully, he says, there we go. We've got a rough idea. We've started to be able to change the color of our flight path. So that's just showing one visualization. And I'm happy to kind of, we can talk through this if we need to, but hopefully people watching can kind of get the idea that it's really fairly straightforward to kind of drag and drop these components onto the form. We could, you know, once we've done that component, like you can see here on the flight data, I've really tried to keep it very simple. Done a similar thing for these little half moon shaped objects, visualizations that we can create, you know, the kind of, well, they're gauges, but they can kind of demonstrate a minimum and a maximum and what the current value is. And this is quite an interesting one. I'll quickly spend a minute or two talking about that. But if I go back to my other page now where I'm just creating these things on the fly and I drag over a gauge, let's just leave that there for a second. We can worry about the placement later. But you'll see in this flight data now, I've got the ability to create these things called measures. So if you imagine the data's coming through, some of the data that's coming through, like, you know, kind of the altitude, for argument's sake, it's not always 0. You know, it might start off at, you know, I think in this example, it starts off at like 9 feet or 19 feet. But we can't always guarantee that our data is going to be able to say 0 is our minimum value, you know, i.e. ground level. Equally, what is our upper limit? So being that we're talking about altitude in flight, I think, what was the highest level that you'd fly at, Cliff?
On the 787, it's 43,000 feet. So above that, you're outside the aircraft limits. So you would want to put maybe 45,000 as a you know, an absolute ceiling of where you go to. So, yeah.
Well, let's do that. Should we do that? I mean, that's the point. So this is where we can start to use these quick measures now. So we don't actually have anywhere in that data. We might be lucky, you know, that data might come through and say, I want to pick the maximum value and add 10,000. But if we did that, our gauge might read up to who knows what.
Yeah.
So at the end of the day, we can now start to use these measures to kind of bring in some of that information. So the first thing we've done, if we look at altitude, actually, no, I won't look at altitude first. I'll just give you this general measure. I've created a measure called min-0. And what that is really set to mean is that anytime we use this measure within our data visualization, it's always going to be set to the value of 0. You can see, you can put in any kind of function in here. You can kind of really make these as complicated or as simple as you like. Mine is really simple. It's min0 equals 0. So, you know, can't really get much simpler than that, yeah? You get the idea. So when
that is similar to like the sort of functions you'd put into an Excel spreadsheet as well, isn't it? So from an office user that is usually doing Excel and the likes, that is the sort of the way they think, you know.
Precisely, Cliff, and that's the whole point, yeah, is that we're now offering these capabilities to a different stakeholder within the business that doesn't necessarily have to have that depth of knowledge of the entire IoT platform. They're now looking at this data using different tools, and that's the point. So min0, if we go back to our little gauge object there for a second, we can see, much like we were putting the latitude and longitude on earlier on, we've got a few different values we can put in. And I zoomed in a bit here just for the sake of the stream, so it's a little bit tricky to kind of scroll up and down. But we've got things like target value, we've got minimum value. So the minimum value we want to use would be 0. So we can use this measure to drop that in there. And now we can start to see that our visualization changes and we've got 0 as the minimum value. So now what do we do about the maximum value? We could get clever. We could do something clever and start to get, as you said, Cliff, you can use really complicated functions. We could go and call anything we like. I'm going to keep it simple again, okay? Because that's how I work, really simply.
I like that.
Yeah, so yeah, absolutely. So what did you say, 45,000 feet?
43 is the ceiling, yeah.
I went for 50, but I'm not a pilot at the end of the day, so I'm
always pushing the limits. John.
Yeah,
always. So maximum altitude 43,000. Similar thing. If I quickly scroll up, maximum value, drop that in there. Actually, it might be useful if I actually just accept that to begin with. Give that little tick a click. And now if I drag that over, In fact, there we go. If I drag it to the right place. So you can see now we've got 0.00k, we've got 43k. We can start to say, well, do I want that k? So the bottom line is we've got a way to manipulate how that scale is shown. If I scroll down here a little bit further, if I can find it. See, this is the problem with having it zoomed in quite high, isn't it? But data labels. So we can say, so for the data, actually, for the data, got to get my head around which one's which now. we can say, right, what units do we want to display? We can say none. So you can see straight away that's taken the k down to a single value. And we can use auto, or we could set auto sort of decimal places to 0. So we're really getting a feel for 0 to 43,000. And the same for the call out value now. So the call out value is that number that would sit in the middle of that gauge. Currently it's blank. And I'm going to do a similar thing, display units. We're just going to, maybe we'll choose thousands now. So now, in theory, if I click on one of these dots here. Oh, hello. Maybe not. There we go. Oh, look at that. So having a great time there. Let me try and drag that down, because clearly it doesn't like the fact that I've got visualizations on top of visualizations there. So in theory, if I click on one of these dots now, hopefully, he says, yeah, nothing's going to happen because I'm doing this live. Of course, that's the way it's going to work.
Obviously.
Yeah.
But in theory, it would be useful if I were to add my data fields in here, which would be my actual altitude. I added the min and the max. I didn't actually add my altitude, which would go, of course, into the value area here. There we go. Now we spring to life. So you can see our call out value now. So basically, why I'm going through this is just to basically show that we can add these data points in there, and we can start to manipulate, and we can start to use the data and get it configured to look and feel how we want it to look and feel. So, you know, in true style, go back to my actual page. You can see I've done a little bit more formatting and presentation, not a lot. Hopefully you'll see that it's fairly straightforward to do what I've done and created this dashboard. So the next thing...
Looks like we've landed.
I think we might have done. Yeah, I think you might be right. Well, we'll flick on to the last bit now. I think we are, Cliff. We are very much certainly
Very close.
descending. We are certainly descending.
I'm still sending data. Looks like I've got, if that's in seconds, about, I don't know, 10 minutes actually. So
Wow.
interesting.
Okay. Talk a bit longer. No.
Yeah.
We've got Q&A, don't forget. We've got Q&A.
Yeah.
Q&A, absolutely. So the bottom line is, right, so you can see we've created our first report. Now that report is great because remember we're using Power BI desktop. So that report's been authored on our desktop. We can save that, which, there we go, I've clicked save. It's called flight data. At the top here, you can see that. But it's on my machine, yeah? It's only available to me to use. And I could absolutely...
We'll ship your machine.
Absolutely.
That's what you do in this world, isn't it? We'll just ship
Absolutely.
your computer.
We just
Well,
give...
it's on my machine.
Yeah. We email it to each other. We could email it to each other. We absolutely could email it. You know, that's an option. And remember, back to that point, it's data. We can access it anywhere and for anybody. But let's do something a little bit more, you know, easy. Let's use these cloud services that we know and love. So you'll see at the top there, we've got this nice big button called Publish. And if I were to click on that Publish button, it would ask me which workspace I want to save that report in. So I'm going to select my Tech Days 2022 workspace. I'm going to click on Select. And because I've already uploaded it, it's asking me, do I want to overwrite it? So I'm going to say, yes, I want to replace that. And you can see, so this PBIX file, which is the Power BI file, you can see it's a very, very Office-esque, has now been uploaded to that workspace. So now at this point, we can flick on over to our workspace. We can give that a bit of a refresh. In fact, we probably don't even need to give it a refresh. And our flight, that is the actual file there. You can see that flight data. So if I click on that quickly, you can see now we've got that version. You can see there's my page one that I didn't delete there with the bits that I was just working on there. They're now up, available online. That's now published. Now, the final thing I was just going to show and explain, I think we mentioned it earlier on there, is just the fact that if I wanted to make that available, and in fact, to get that file up into the camera in the stream, that was shared with other people in the production crew that were able to log on, show it on a screen, and have it presented out over the stream. So that is the actual report that's been used for the last few hours. And with that being said, I think we are pretty much at the end of that Power BI session. I don't think I've missed anything.
I don't think so.
That's
Short and
awesome.
simple.
That was awesome. Well done.
So there's a few calls to action there. There's a few links to, it's obviously Power BI Learn modules, fantastic content on Microsoft Learn, of course. It's always great to go. The other thing I was going to call out, and I had a chat with Sandra about this actually. In fact, I'll quickly go back to show this. I didn't actually get it up and running for this event, but because Custo Query Language was spoken about so much during the session with Sandra, use Data Explorer. There is actually a plugin. If I were to create a new report now, I could actually use Power BI Desktop. I'll quickly show you what it looks like on the screen. I won't log into it to save a little bit of time. But if we log on, we're creating a new report. The first thing that we need to do is get some data. Now, if you remember, I used the data sets that were stored in my workspace. We can actually click on more here, and we'll wait for that to come up.
I think this might answer one of the questions we had in the chat. Actually, was about using things like Postgres and other data tools. So they're all in there, aren't they?
Yeah, absolutely. I mean, there's loads. You know, at the end of the day, and this is the point again. You know, we want to be able to connect to multiple data sources. So the thing is, we've got this connection that we can create to Azure Data Explorer right there. So if we did have that Azure Data Explorer cluster sat in our Azure subscription, that we had all this data, we could actually query that data set directly from Power BI. So we don't, which effectively would remove the need for having that stream analytics job pumping the data out into a. So the point is, Power BI is, as the name suggests, quite a powerful tool. You know, you've got to hook into many different data sources, and as you can see there on the screen, there are many different data sources. So yeah, quick shout out there. So in the sense that what Sandra was showing earlier on with being able to query Azure Data Explorer, you can absolutely do the same thing using Power BI as well. So
awesome.
With that, yeah, like I said, I think that will get me to the end of the session. A few call outs there, some Learn modules around the Data Explorer and Power BI, and one around designing effective reports, because as you'll probably see is that whole, you know, creating visualizations. There's lots you've got to think about, you know, certainly around the kind of the diversity, inclusion, the accessibility side of things with people with, you know, kind of problems with their vision, potentially color blindness. Yeah. So there's great things and there's great tools in the Office suite that'll help you design those visualizations. Awesome. So there we go.
Thank you very much. Yeah, awesome.
Yeah, thanks for having me.
Yeah, I really enjoyed that.
And congrats on the new Microsoft job.
Thank you very much.
We've got someone on the inside now.
I have.
Yeah, well, you know.
So at that point, that's the end of the sessions area of what we were going to do today. What we've done is left some time right at the very end so that we can speak about your questions, which there have been some awesome questions along the way. We've brought Sandra back into the live area, and we have Maria-Anastasia and Jose joining us remotely for this part of the event as well. So thanks first to all of the speakers and all of the crew and everybody that's been involved in this event. It's been.
Thank you to the people that have attended on you know, on the different streams for coming along and, you know, watching this flight into IoT long haul.
Yeah, it's been really cool. I really enjoyed it. So
we landed.
No, I think we've got.
I'm not sure if we landed or not yet. Adam can maybe flash the screen up.
Yes, soon though. It's probably within the next 3 minutes we will land. So during this Q&A session, we can flick back and we can have a look.
Well, the altitude's 434 feet at the moment, descending good. So we are literally just about to land. So I think we timed it really, really well.
Yeah, it's not bad. Yeah. So what we've done is essentially this is a 9-hour flight. So we've just multiplied it by 3, just over 3 actually. So we can fit it within our 3 hours. And we started it just before we went on air today. So we will land shortly, in fact. So, you know, you should be giving your cabin announcement, telling the cabin.
They would have had the cabin. Yeah, they would have had that by now. Yeah, I mean, 300 feet is it's quite late in the flight to be telling them to take their seats.
It probably is. Yeah, they ought to be sat down by now. So yeah, at that point we can go ahead to the questions. And yeah, there's been some fantastic questions actually, and just scrolling around in the list here. There was a question about the number of, and I don't know if I'm going to go ahead against the grain because I don't know if questions are going to get queued up for me and asked, or if I'm. So we'll go to the first question on the screen and we'll go that way.
There somewhere.
Please hold. We're taxiing.
We're taxiing in.
Yeah, exactly. Yeah, that's what's going on. No. We can just go through the list of questions. It's fine.
3 hours, all this tech.
Yeah.
Azure Data Explorers, Power BI, and we get let down by
Yeah,
Put a
well,
question on the screen.
if everything worked, then people wouldn't think it was live.
There is that. There is that.
I'm going to go.
We answered one earlier, which was someone asked about Postgres, taking Postgres from Azure and putting it into Power BI, which I think you answered anyway.
There was a good one on where does this fit with
IoT Central.
IoT Central.
Yes.
I love IoT. It's a bit, I'm a big fan. I mean,
yes.
I'm now gainfully employed with Avanade, but before that, 12 years I was a consultant. And having this service that you can use to fast track a lot of the technicality underneath what we've seen today, IoT Central builds on top of all of that and obfuscates a lot of that detail. So you can set up device models. You can use things like plug and play, which is a way for devices to be able to announce their capabilities. You connect them to IoT Central, and at that point, you get access to, and this is an interesting thing, things like time series insights. I'm not quite sure what that IoT Central team are going to do to replace the TSI element in that, but I'm sure maybe bringing in Azure Data Explorer was what they would do. And then you can view all of your data directly in there, make nice dashboards, and you've got full granular control for authentication and permissions in there as well. So
the good bit about it is they've taken all the bits that you would normally need to use if you're just going to set up an environment, like IoT Hub and DPS, which is device provisioning service, all these bits, and they've basically put it into one service. So it's a one-stop shop for all of your IoT. Now, the thing you need to think about before you go and, I'm going to use Central and just dive in there and use it is the fact that IoT Central, the payment method is per device. So it's a great way to set things up and try and proof of concept. And if you've got a small install base, a couple of hundred devices, then it's fine. But you go above that, you start getting into many thousand devices, or you want to do something really clever and out there, then you may want to look at building it yourself, IoT Hub. But it's a great place to start. That's what I take away from it anyway. Yeah. So, and if you're starting out and just playing with this, it's a fairly cheap and free. I think you get a few free devices, don't you?
Yeah, 2 or 3. Actually, the power for it, for me, from a consultancy point of view, was the fact that I can build a solution which is fully working for a client and leave them with it, and they can operate it. From a consultancy point of view, if I was to build what we built today, they would then need to probably keep someone like me on board to carry on developing it or maintain it. So that's where I found the power. So I used it quite a lot for my clients. Yeah. It's great. You're not trapped in it either, because you can actually export, just like with everything. You can export all of the messages you send out to anything you like, a storage account, or out to a service bus or an event hub, and then use that data further on down the line. So it really can be a stepping stone into other things as well. So
any other questions?
Yeah, there's heaps. Oh yes, here we are. Other devices. Oh yeah, this is a good one. We saw this in the chat.
It's not that I know of.
Do you want to read the question out?
It says, the question says, are the devices IATA approved to use on planes in the real world?
What's IATA?
IATA is International, I can't remember now.
Aviation
Same cover. Yeah, I did Google it earlier as well, just to remind myself. But IATA is basically, you remember, you get the airport codes, and that's what everyone thinks of, the IATA and ICAO airport codes. So Heathrow is EGLL as opposed to LHR. So they basically set the rule set around aviation, what can and can't be done. I'm not aware of any devices. Certainly these that are on the bench in front of us are not. Obviously, devices that Boeing and Airbus and Bombardier, those sorts of big companies make for aircraft would be approved. I'm not sure IATA would be the agency. It'd probably be the FAA and CAA in the UK. But yeah, not IATA. They're more about the rules around how passengers are handled and the airports and things like this. But yeah.
What is interesting though is that if you look, there is 2 Raspberry Pi 4s in space.
There is.
And you imagine the amount of red tape that they had to go through to get those Raspberry Pis on the space station. I know originally Tim Peake took a couple of Raspberry Pis up there, but they've been replaced since. And yeah, I know that Eben Upton and the team down at Raspberry Pi have done an enormous amount of work. It's not straightforward. It's a really pertinent question, actually, because you can't just do what we do here and actually expect it to go through. I know Cliff told me a story that they actually look for suitcases that have got tracking in them and perhaps destroy them, or if not, don't let them board the plane. And...
No, there's I can't remember which country it is now. It might be the Netherlands or Germany or somewhere. They've banned Apple AirTags in the luggage, and the reason was quite simply is because people are looking at their bag on their iPhone and saying, well, my bag's not on the plane yet, not realizing that the baggage handling system in most airports is deep underground. And there's no data connection, obviously. And then by the time your bag gets put on the plane, it's now in a Faraday's cage, so there's no data signal. So they think their bag hasn't got on the plane. They want to get off because, well, my bag's not on board and I need to get off now because you haven't loaded my bag. And they had all sorts of passenger issues. So they've just banned Apple AirTags on bags,
Nice.
which I thought was a simple way of solving the problem.
It is. Yeah, I like it.
I don't think the passengers are paying attention, but you know, so there you go.
The next question is quite a long question, so I'm
Yep.
going to abbreviate a little bit. And really, we've answered it during. So it's how we can use indicators in the data to generate alarms. So we saw some of this in Maria-Anastasia's session about stream analytics, where we can write queries over data, and we can either just use the raw data as it comes, or we can integrate AI into there as well for things like spike and dip. And that's something that we can then use those alerts to fire off things like logic apps, or indeed awesome visualizations like we saw in Sander and John's sessions there as well. So yeah, you can absolutely do that. And it's one of the most powerful things. I mean, you are processing your stream of data. You need to do something with it other than just put it in blob storage, really. That's good. So next question.
It says, can we do a scoring request using ML model deployed as an AKS endpoint inside the function tab of Stream Analytics? I think that's one for Sander.
I'm going to give Sander that one.
Yeah, Sander, there you go. Catch that ball. Yeah.
Well, I have to look into that. There is some, well, if you go to the Azure portal, and there where the functions can be added, there's also an option to select a running machine learning model, which is running as a service.
That's right.
Or you can attach the endpoint of the service. I'm not using it myself that much, but then it gets a functional name, a logical name, and you can add it to your own query job.
Yeah, I bet you can integrate ML Studio and everything into that. It wouldn't surprise me to be able to output from something like that.
That's an interesting thing that I want to research.
Yeah,
that's
because into IT3.
Or just watch Sander's blogs. He puts out some awesome blogs.
Yeah.
I dare say in a week's time he would have answered that in detail.
Yeah. So next question is, does a single Azure IoT hub support multiple different types of IoT devices? And yes.
We've got three here.
We've got three here, but you can go right down to a really low level, and it's really about resource limitations and your communications limitations, perhaps. And we can see, I mean, the Python, MicroPython driven P code that we've got here, that's using MQTT, but actually you can go even further and you can go down to HTTPS and just send raw HTTP traffic to the IoT hub in the correct format and the correct, headers and everything, and it will work. And you can absolutely do that for really resource constrained devices. And yeah, I mean, somebody has created just a phone app that behaves like an IoT device, which I thought was quite a great way for people just to be able to download and start playing with things like IoT Hub. So yeah, anything you like, so long as you are using the correct security, of course. And, there is an S in IoT. It's just a silent S.
What, the security?
Yeah.
IoTs.
Yeah, go ahead.
Yeah. What would your cheaper alternative for digital twins for devices that aren't as sophisticated and expensive as the planes used in the example? Cheaper alternative.
I wondered if the question is about the service or the question is about the cheapness of the device. I'm not sure. So you might be able to tell us about how much Azure Digital Twins the service costs. Or roughly. Obviously, there's a pricing table, and it's going to depend on usage.
Well, I recommend to first look at the price calculator of any Azure resource.
Yep.
There's a pay-as-you-go part in there, in how many events are generated, and from what I've seen, it's quite cost-effective.
Yeah.
But start testing. Do a skill test, a load test. As with every Azure service.
Yeah.
Don't trust that it works for 10 devices, so it's still cheap for 1,000 devices. Start doing simulations for a couple of days. It will run for years. So if you want to know if you're in trouble within the next couple of weeks, do load tests.
Yeah.
Nobody wants that big Azure build, do they?
No, not really.
So.
Well, you normally always write a simulation of an actual device because you don't have that much of test devices. So if you have a simulation of it, then you can multiply it and run it multiple times, and then you have your data load.
You have your data load, then you can then see your spike in the cost. But the calculators I found on the Azure portal and website are awesome. The fact that you can put in there all the parts you want. It's got the right questions about that service. You can fill in the boxes, and it will tell you what it's actually going to cost. And I've often found that it's actually been on the calculator's been on the higher side of the actual physical cost.
The hardest part is the estimation on your side. So you've got to have some idea about, I mean, generally like number of messages would be a good count. So you've got to work out number of devices, how often you're sending it. If you do the IoT exam, that will be a question in there.
Will be, yes.
So you need to work these things out anyway. If you're going to move anywhere near production, you're going to have to know this, because otherwise you'll get that shock Azure bill and somebody will tell you off. It may well just be your own credit card company or your boss. So yeah, that would be bad.
This is probably one for Sander as well. Is the Custo Detective Agency tool a great way to get familiar with KQL?
Well, yes. KQL is the abbreviation for Custo Query Language.
Yep.
And that's where it's all about. There are a number of challenges, like there's a bank robbery, and you have to try to figure out where the villains are, somewhere in the city. Or there's some election fraud, and you have to figure out who was the fraudulous person who wants to get elected.
That would never happen.
And there are multi-step, which are really nice, that they even use Google Maps as part of the challenge. I don't give too much away.
Are they free doing these?
And they are for free,
okay,
and you
awesome.
Get the tags. You get some
the badges.
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 Cool.
The Learn badges. Yeah,
and
cool.
there's even some stuff to win. So
I like it.
Actual stuff
Check
that's
that
sent
out.
to you.
So that's as much questions as we could take. Sadly, I mean, again, we'd stand here all day. So I'd just like to firstly thank all of the speakers and organisers that have been involved in this event. We've had an awesome time. Thank you so much for coming along as well. We will be following up with a blog post.
Do we have the picture of the airplane?
Yeah, we should land. We should have already landed in
we should have landed. Yeah. Thanks to the team behind the scenes that helped put this together as well. Not just those in the room, but others as well. Also, thanks to José and Maria-Anastasia for joining us from different parts of the world. And yeah, you can reach us. We're all on Twitter. Probably the only ones left on Twitter, but we're still there. You'll probably find us somewhere else on one of the other channels, or reach out to us. And we'll answer any questions you have. That if you think it up as soon as the stream finishes, then reach out to them. We're trying to
we love questions.
Yes.
Love that sort of stuff.
It's an excuse for a blog post. That's what it is.
It is. Yes. And obviously, go get certified. Go do the exam. Go do the 30 days to learn it IoT challenge. Go read all of the Learn docs, and take your IoT career to another level.
Yes.
Thank you very much.
Thanks a lot. Bye, everyone.